get through the agendas for today's meeting. So if you the agenda for today's classes, we will understand what is Elasticsearch and how Elasticsearch is different from the traditional database which we used to have like MySQL or MS SQL, and the various terminologies involved in it, like the shard, documents, index, primary shard, replica, node, cluster. We will understand what these terminologies are, and we'll also understand the architecture of the system and the installation part. So have you installed before? Have you installed this new machine before?
No, no, no.
Okay, great. So if you face any difficulty in understanding any of the point, or if you face some difficulty, you please you are free to stop me, okay? So that I can
Sure.
discuss you in detail about that. Okay. So if you read the first point, you might be seeing that there's a jargon calling something called real-time distributed search and analytics engine. The point might look very simple, but it contains like a lot of hidden information inside it. If you just understand what is a real time here, so real time is meant by like there are kind of two kind of systems are there in the market, computer systems. One is the real time and near real time and the batch processing system. Have you heard about these terminologies before, Matthew?
Yeah.
Okay.
I heard about real time and batch processing. Nearly real time. I mean, that concept I'm not that much familiar.
Sorry, please come again. Batch?
Yeah. Yeah, I heard about this real time and batch processing systems, but this NRT concept that is not much familiar for me.
Okay, NRT is kind of very similar to real time, except the difference is it has like a few seconds delay. Like if you are
Okay.
watching a live telecast match on a TV, it is not
Mm-hmm.
real time, right? It is providing just the near real time. At least there will be like few seconds of delay in the live telecast, right? Do you agree with me?
Okay. Yeah, got it.
Yeah, there's no big difference on the near real time system. So the reason I mentioned here, the point here is a real time is like in Elasticsearch, the system or the data, whatever you index into Elasticsearch, can be visible to the user in three modes. One is the real time, near real time, and the batch mode. Batch mode is not so prevailing here, but the reason why I just pulled here is if you check for the competitor product of Elasticsearch, you might have heard something called Solar. But nowadays, if you see on the market, all the companies are going towards the Elasticsearch, not for Solar. So the main difference between Solar and Elasticsearch lies in this factor. So Solar is a system which works in the batch processing, but in case of the Elasticsearch, it works on the real-time mode. So there is a difference here. So
Okay.
like there's a parameter in Elasticsearch in which you can configure whether the search results can be a real time or near real time. It is completely configurable. It's a user control behavior. Okay.
Okay.
And then you see something called distributed search. And this is like a most important, most pressing concept here. Let's say, let me start with an example here. Let's say you are in a classroom with a faculty. Suddenly faculty comes in and start giving the mark sheet, and she wants to someone to total the mark sheet or the transcript which she has. So in generally, the faculty or teacher gives the mark sheet to the student. Let's say she gives to the one student. Let's say they have 50 transcripts. Even let's assume that the student can compute the total in less than 1 second, maybe 1 second. So it will take like 50 seconds to compute the result. Do you agree with me?
Yes.
What if the same faculty tries to give the mark sheet into 5 people? Maybe she decides to give the mark sheet to 5 different people, then my time or the throughput time was actually reduced to 10 seconds, right? Do you agree?
Right.
So this is the key fundamental concept here. So if I have my large amount of data to be processed, if I divide within like multiple machines or a node, so I can improve my throughput time. So that is the key essence part here. Okay. So
Okay.
if you increase the number of people to work for a given job, definitely there will be increase in the throughput, and that is the idea here.
Okay.
So similarly in computer also, let's say if you have 10 GB of data to process or do after search, then your searching time might be difficult if you having only one machine, because it all depends on the hardware and the software, right? So let's say
Right.
if you have like 10 machines which you can process or helps you to compute, then you can get the speed in a much faster rate. So that is the main concept or the idea overall here. So you mentioned that you have a database administrator, right? What is the database you
Right.
have worked before?
MySQL and MariaDB.
Cool. In MySQL, have you did partitions?
Partitions I have not actually did, but I know the concept.
Okay. So if you have done the partitions or if you heard about partitions before, you might have seen that they do partition for like a very large table. So they divide
Right.
into like small pieces to improve the throughput. Because if they have like a 10 million or 100 million records in a table, the table speed, travel speed is actually heavily affected. So they divide the pieces into multiple chunks based on some hashing number, like hashing based on the ID or some different condition. Based on that, your document will be split equally across the machine. Now, across the machine, in the same machine, into different pieces. So that is like one level of part improving the speed of a system, and which is something called the same node partition. So the partition what we are speaking in the distributed search here is the same partition pieces will be divided into different computers.
Okay.
You are understanding what I'm saying, right?
Right. Right.
So that is the factor here. And then there's something called the replica. Let's say the same example, if I divide into 5 pieces, like for same classroom, I can get in 10 seconds. What if I have a replica again? So again, this work as a duplicate replica while you're reading it out, then my performance further increases, right? Even though some
Right.
student didn't turn up, the other people would have who been assigned the work can take up the work and complete it, right? So that's where the distributor concept actually comes here. You got it, the overall big picture, right? How distributor search really works.
Yes.
Great. Then you have a word called something called analytics engine. So what comes to your mind? Someone says analytics engine here.
Analytics engine, probably they do some evaluation on the data which you are processing, decision
Okay.
taking kind of.
Okay, understood. So if you have had experience in dashboard and the other stuff, you might have seen that people would retrieve and see like last 15 minutes what's happening in the system. So in general, there are like four kind of analytics there in the market: descriptive analytics, diagnostic, predictive, and prescriptive. So these are the four verticals of the any analytic systems available in the market. So general dashboard analytics, if you encounter, you might have seen something called descriptive. So whatever happened in my system, you are able to see in a dashboard view. That's the analytic part. So with Elasticsearch, you can do like analytics what you can do in MySQL or MariaDB. Like you might have used something called min, max, count, and those kind of mathematical operations, right? So if you want to do
Right.
like how many people have did this operation, the analytics view, everything can be done in Elasticsearch also. That is
Oh,
the fundamental idea over here. Then
okay.
there's a point something called Apache lucene. Have you heard about Apache lucene before?
No.
Okay, Apache lucene is a library on which Elasticsearch is built top of that. So I said
Okay.
it's a library, but Elasticsearch Stack is a like complete framework. So you know the difference between the framework and a library? Any chance?
Um, I know about the library. Library means a group of predefined functions and all.
Yes, you are right. Yeah, great.
Not wrong. Then about the framework, you may have to explain maybe.
Okay. So, can you think of some example for frameworks available in the market?
Uh, I think this Python is having some framework which is called or I don't remember the names. But,
Okay. So, have you heard about something called .NET framework?
yes, yes, yes.
You might have heard something called .NET framework, AngularJS as a framework, React as a
Right, right,
framework, Django. But
right,
the
right.
funny part, if the funny part is jQuery is a library they call it, or the logging system they call as a library. They don't call as a framework. Then there is a solid difference between the library and a framework. Now you come to a point, right? There's something fundamentally different between the library and a framework. Do you agree?
Yes.
Okay. So the main difference between a library and a framework is library you can use it in the way which you like to have. You understood what I'm trying to say? Library, you can
Okay.
use it as flexible as you want, but in case of a framework, you have to follow their own script standard for that. So if you even want to create some standard class or template, you have to follow the standard what is being in the framework, which you can't do it normally.
Okay.
So that is like a
Yeah, yeah. Okay.
great. So, as we discussed a few minutes earlier, the library you can use it at your convenience, but in a case of framework, you have to follow their norms. And one more
Okay.
advantage of using framework is frameworks comes with almost all built-in boilerplate stuff. What I mean by boilerplate stuff here is all your security, authentication, and the encryption. It all been satisfied by itself. You don't have to worry about the security aspect and most of the stuff. If you take a .NET framework, you almost have everything as secure as possible. But if you think like if you want like a secure jQuery application, that is not possible. It is up to your responsibility. So the main difference, what I would say is, actually, I'm hearing a lot of noise from your side.
Just 1 second. Hello.
Yeah, yes.
Is it fine now? Some construction works are going on outside.
Oh, right. It's 2 minutes still. Why? Yeah, it will start by 9 o'clock, right? Why are you starting by 8 o'clock itself?
Because see, the person told me that it's only from 8 to 9.
Oh,
Uh,
interesting.
if you do, if you do have sessions after 8 o'clock, I mean, I can go to my office and I can take this call from there.
Okay, I have office. That is a problem. After
Okay, okay,
9, I have to be in the office. That's the problem.
okay, okay. So normally, what time do you have sessions in morning?
Morning, I start from 6 o'clock. If the candidate just want to join, we start from 6 o'clock. 6 to 9,
Okay,
I'm available. Or else I
okay,
take on the evening part. Evening in sense like from 9 to 12. So now there's a batch going on for people from 9 to 12 who are staying in UK. So that's batch is already going on. That's why yesterday when Mind Magic's call, I said, you please schedule on the morning part. That is the case here.
okay, okay.
So you want to change in timing?
Um, right now, I'll just check out for 1 week because maybe from tomorrow onwards, I'll reach office little early. Then this sound issues will not be there.
Okay. Yes. Try to see, or else we can come for a better idea or a better understanding of time what we can work.
Okay.
No problem. So next part is like it is, and one more difference what you have to understand on the Apache Lucene as well as with the Elasticsearch is like I'm already said that it's built on top of Apache Lucene. then how could be more different? What could be the more pressing factor? So it's already built on top of Apache Lucene. If you search on Apache Lucene on internet, you will be amazed to see that most of the feature what you see of the Elasticsearch it's already available on Apache Lucene. Then you might have an encounter strange question. Then what I'm really doing with Elasticsearch? That question will most of the people will understand. Okay, all these features are there. Then what I'm really trying to do with what is it called with Elasticsearch? If you carefully observe, all the logging part or all the clustering ability is being done in the Elasticsearch, not on the Apache Lucene. Apache Lucene is like a Java-based library, so only the Java-based system can interact with Elasticsearch, Apache Lucene. So if your application is running Python or C Sharp, then you don't have a choice. One second.
Yeah.
Hello.
Hello.
Yeah, can you hear me better now?
Yes.
Okay, I switched from mobile to desktop. That's what I used to do, but they had a problem in my starting my desktop. So now can you see able to see my screen?
Yeah, I can, but I can also see share your screen some pop up.
Yeah, I'll disable that. So what's it now?
No, it's still there.
Still there. Where do you see the pop-up? Is in the top left or
I mean,
where do you see?
it's covering the entire screen.
I think it's for you, I guess. Can you click on cancel for you? I think it's the prompt for
Oh,
you,
it's
I guess.
yeah. It's mine. It's mine. Sorry.
Yeah. Because I actually made you as a presenter, then I changed to me as a presenter. I think during that time it might come for you.
Oh, okay, okay. Yeah, it's gone.
Yeah, great. So we were discussing about the Apache Lucene, right? So all the
Right.
clustering abilities were not part of the Apache Lucene, and one pain point in using the Apache Lucene is you just have to use your Java-based application to interact with Apache Lucene. Let's say if you tomorrow come and say that I have like a system which I can Python or C Sharp, I can't directly interact with the Apache Lucene. I have to relay support on Java. I have to interface in somehow to get the job done. But what Elasticsearch people have did is they wrote a wrapper. So that wrapper consists all the capabilities of the Apache Lucene, as well as they added like more functionalities to that. So kind of functionality, what you see like the clustering ability, distributed search, and few analytics operation. Then the another important thing is all the interaction to the Elasticsearch has been done through the help of the REST API. So earlier the system was interacting with the Java, but if you want to interact with this kind of system, everything comes with the REST API. Now the question would like you would like to ask would be X, why REST API? Why not like other interfacing mechanism? So the REST API is like a beautiful concept or the idea on the whole. REST API protocol can be understood by any language which is being popular right now. Starting from C, C++, Java, Python, or Scala, any programming language can understand the REST API so easily, so it can interact with Elasticsearch without any much of problem. So have you used REST API before, Macube, before that?
Yeah,
Any experience?
yeah. In current project, we have a system. What we did for the current project is that we build a data warehouse, and on
Mhm.
the top of that, we build a dashboard system for our customers.
Okay.
Now, this interaction between this particular dashboard and the database is happening through the RESTful APIs. I mean, REST APIs are using for that. I mean, to take the data and do all this kind
Okay.
of
Okay.
activities. We are using something called a Dream Factory.
Okay. Okay.
So
And
yeah, I'm familiar with that. So
okay.
basically, our intention is to we have an application, as I told you before, which is generating n number of log files. Our interaction,
Okay.
our ultimate aim is to read all these log files, which is generating by this application, and
Mm-hmm.
we create it with this particular dashboard.
Okay. So understood. Okay. So you might have already heard about REST API. So there are like
Right,
four kind of general HTTP verbs, which is the get command, post, put, delete. You might have heard these commands. If not,
right.
we will see in detail about that in the while we doing the querying part. So the
Okay,
last fourth point, what you see is something called schema free. Being the people you experience in the SQL background, so always we know that if you want to create some table content, first we might have to create a database, and then we will create a table with the properties. What I mean by properties or the schema here is, we will say that create table name, and we will open the bracket and say what are the different columns it can contain along with the field name, correct, right? The field
right,
data type. If it's a name,
right,
so we define the value 255. If it is age, we define a shortened or int. We try to define the what is the data type of the column. Then once it's done, if you want to index, we also try to enforce the same principle. If there is any deviation in the data type, then you are not allowed to do that, right? So, but
right,
in case of Elasticsearch, there is no hard restriction saying that only these data type we have to define the data type before even you start working. It's not like that. It is like kind of very flexible. So before even you want to put some data and start playing around in Elasticsearch, you are not required or you are not obliged to create a mapping before that. So the word what we call in SQL is the schema, but people in the Elasticsearch would call as a mapping. So that's like a
okay,
small transition from SQL to Elasticsearch. Okay.
okay.
Then you see something called open source here, right? So the
Right,
all the components of Elasticsearch is being open source. If you just go to the GitHub page, you can get the complete control, and you can get the overall understanding what is Elasticsearch, and you will get the complete source code. But you can't contribute back. Only the Elasticsearch company can work on the changes and can push the changes to the master. But anytime if you wish, you can locally change some, make some changes to the code, and you can keep it locally if there's a diard need for you. Then you see
okay.
something called document-based database. Like the have you heard about CAP theorem before, Matthew?
Not really.
Okay, CAP theorem is like a theorem which helps us to decide what database we like to pick it up. So generally, like now, like three kind of flavors of database came into the market. One is the SQL database, and one is the NoSQL, which you might have heard about. And there's
Right,
one thing, something very recently came up, the database, something called New SQL, something called NUW. New SQL is
okay.
kind of very stable market, which has the hybrid feeling of both the SQL and the NoSQL. So you can interact with the system through the traditional SQL language, which you know, but it
Mm-hmm.
contains the properties and features of the NoSQL. That's something very cool and fascinating, right? So you are
Right,
without losing your SQL behavior or SQL knowledge, still you are able to use the benefit of NoSQL. People actually went to NoSQL because they need to scale the system when the workload is pretty high, which was not possible with the help of MySQL. MySQL found it very hard scaling after like 400 million or 5 million record. It found really hard even to do a small search on top of that. But if you think like a 400 by 500 million on a distributed mode, that is it's nothing. You can get the result in a few seconds itself. But in case of MySQL, it might take even 30 40 seconds even to do a count operation. So that is the big difference what people say here. And it comes under family of NoSQL, and the NoSQL family also has like a lot of divisions here. If you
open and see the NoSQL here, there are like a three kind of a database system would be available for a NoSQL. One is the key value pair. Just click on here. Key value graph and other stuff. Can you see here?
Yes.
Key value, document based and column based. The column based and all will go for the HBase and Cassandra. Document based will have something called MongoDB and Elasticsearch
Yes.
and these database. Key value pair of the Redis are the Memcache, which you might have heard before, right?
Yes.
So these are
Yes.
the different formats or the different kind of database available for the NoSQL market. If you just see, this is like a column family graph, document, and the key value pair. So these are the different format here, and our Elasticsearch comes in the format of the NoSQL here.
Okay.
NoSQL in the branch of the document base. That's the key idea here. Where's the document? Yeah. So this comes under this. Oh shit. Yeah. And next is like who are all using the Elasticsearch. Almost like major companies in the world are using it, using Elasticsearch. But you might have used GitHub and Stack Overflow, right?
Yes. Yes.
Can you think where Elasticsearch is being powered or being used? Can you make a wild guess? I'm not expecting correct answer, but you can make a wild guess. It's fine.
Is it on the search option? I mean, on where we are searching for something on the top.
Yeah, you're right. Almost right. Anything else? Oh, that's kind of very perfect. Then anything else?
Mm, or
Even for
maybe.
case of Wikipedia, it holds good. Even Wikipedia is using Elasticsearch as a backend engine.
Oh, okay. So basically, Elasticsearch is a document-based database, right?
Yes, you're right.
Okay.
So the people where you might have seen this, but you are not maybe we are not realizing where it is being used. Let's say let's go for Wikipedia. When we go inside that, and if you do like a searching part on the search bar or in the any repository of the GitHub, the first part let us say something called maybe computer. Can you see as I start typing, my solution comes based on my string what I input. Can you see here, right? So this is
Yes.
something called autocomplete feature in which the people call it. This is also available in Google, right? If someone goes to
Mm-hmm.
Google and start typing what is there, we start getting the document related to the word which we start typing, right? So that is
Yes.
like these features also being powered by Elasticsearch. This is something called autocomplete feature. And the another
Oh,
feature, as you said, search is also true. If you go for any GitHub document and if you're trying for searching like a specific entity, let me go for a repository. Maybe I'll search for Elasticsearch. Yeah, I'm just choosing the Logstash. If I want to search something called REST, I'm doing in the same repository. You said your search result is being powered. It's true. But there's one more another feature is being powered here is, can you see the highlightation option here?
yes.
This is also powered by the Elasticsearch. This is something called highlight feature. Even this feature is also available in Google. If you search for any document, let's say Logstash and analytics, if you just say here, you might be noticing, can you see the highlighting feature here? It has been dark here. It's not highlighted entirely, but the letters
Okay.
are made highlighted here. So these are the features are generally available in any search engine. So that is what
Okay.
I want to convey here. And why you just also understand why people are suddenly using Elasticsearch for your log processing system. Like any system, the log generation system, it's kind of very weird compared to other systems available in the market. Let me ask you this question: why not choose the MySQL instead of Elasticsearch for pumping the data in the pumping data into Elasticsearch? Can I use the MySQL itself to do the job? So, what do you think the pain point you see the difference?
The main pain point while we are reading the logs and putting into MySQL, it's we have to convert that particular unstructured data into a structured way. So that
Okay.
is really at most of the times, because the logs are like writing it its own way, and to make it into a structured way, it's really weird, and it's not worth it to do that particular job. Even I can store everything, but while retrieving back, user has to read that particular log again and again, right? And searching from there again, it will be very difficult.
Okay. You're almost there, but I'll say a different note point, but that will contradict your statement. What I'm trying to say is, even if you are using the Elasticsearch, most of the time, not entirely, most of the time, you will also convert the unstructured data to structured data. Like in a proper JSON format, you will be converting it. Then you might
Okay.
question yourself, okay, then what could be the real pressing factor if I have to use Elasticsearch than the database? That's a question we have to answer ourselves. You said right, like a word called unstructured. If my document contains a fully unstructured, what can I do? Like a log file is something very rudimentary which you can handle. But let me give you an example of a Facebook post. Let's say you are in a Facebook or LinkedIn, you create a post. For that given post, you let's say I'm start commenting to the post. What will happen? You're not sure that how many lines I will comment or how many characters I will comment. Do you agree with me? I'm not
Yes.
sure sure of the length, and you're also not sure of the what is the content I will be typing in the document. My document can be like spawning, like it can contain multiple information. Let's say you posted some photo. I might say that okay, you remember this story like last year we went for this place and we had a great time, and this is the incident happened. It was very enjoying and thing, and I'm just ending with the thank for this information. This is the proper unstructured data, what comment, what I mentioned. It contains the place information, their time, and the emotion factor, like lot other entries here. If I want to do with these kind of system, if I want to do it in MySQL, strictly there is no option for me. The searching capability is like a way harder. If you want to do like a full text search, have you heard of something called full text search in MySQL before?
Full text search is something like a string search kind of thing, right?
Yeah, you might have used something called like operator, right?
Yeah,
You
yeah,
might have used
yeah, yeah.
like operator
Yes.
using a regular expression.
Okay.
As you might have seen from your experience, people will always not recommend using a like operator because it's something called very time consuming and heavy, right?
Right, right.
Yeah. So, but if you go for the systems like Elasticsearch, if the data is more of unstructured, contains like lot of moving part, you are free to use your free text option in Elasticsearch. If you just say that just like a few words, what you remember, you can get the content just like that. Even if you open your Gmail box and start typing for some email thread which you remember the faintly, that's a usual scenario, right? You might remember like few lines from the subject and few lines from the document email. If you want to search, if it's like a traditional search system like a MySQL, you have to specify the content exactly without even a small spelling mistake. Do you agree with me? You will be searching
Yes.
exactly, but what we see in our Gmail or other searching platform is even whatever comes to our mind, like approximately, we give a random item on that and we are able to retrieve the content back. So that is the beauty here. That's something called full text search. You can utilize your full text search or a partial search result from the system. So these are the benefits, what I would say, from migrating from MySQL to Elasticsearch. That's the fundamental difference. Now let's understand what is the key or the pressing factors between the database and the search engine. Okay.
Okay.
As you might have worked with database, you might have used all the four operation: create, read, update, and delete. So the MySQL, if you think, do you think MySQL is designed for all? The performance would be very similar for all of it. The create, update, delete. So there is no big problem. But what I'm saying in the case of search engine or Elasticsearch is the main goal of Elasticsearch itself is for the search operation. Then if I said it's only depend on search operation, I will be turning off the other parameters, like something like the reading, update parameter, deleting everything might be slower, but my searching capabilities may be much faster. Because earlier when people designed the database, they thought they have to like persist the content. Now the world has been evolved in a so drastic way, like the advent of big data. They like to crunch and see get the volume of data in such a faster action. So what people do, they want the power to be more powerful. So Elasticsearch itself is being designed keeping in mind of the searching capability. That's the difference here. Okay.
Okay.
And the second important point, which you might know, like search engine operates on text data heavily. Like I said, the blog post or comment, it can operate so easily. But if you still want to store the same amount of data in MySQL, you can use something called text field or a long text field, which you can still use it. But the searching capabilities will be much poorer and performance starts to degrade when the document gets very higher. But the traditional database system are ready to work with the table, which is something called rows and columns. It can work so easily. So that's one difference. And the third difference, what you see here is like Elasticsearch are powered using the algorithm, something called TF-IDF or BM25. This is like a very important difference you would see. And the algorithm powering the MySQL is something called B-tree. That's the algorithm is powering the full backend processing of the MySQL engine. And the fourth
Okay.
and important property, what you see here is Elasticsearch doesn't have the security and transaction behavior on its own. Everyone, if they have access to the Elasticsearch, they can control the system. But we know that in MySQL, we can have like a final role-based access saying that this people can only read, these people can only update. We might do having the complete privilege by flushing the privilege. We can get the complete control, saying only admin can create and delete. So we'll have a full control, right? So these kind of
Right.
access control can be done in the row locking, table locking can be done in MySQL, but there is no such concept provides in the case of the Elasticsearch. Everything is open. So people might wonder how they can give a security in production. So generally, people what will do is they keep a engine kind of server. They keep in a reverse proxy. So people who are using the Elasticsearch from outside world does not know the IP directly. So they can only interact through the engine server. That's the way they do it, or they keep it behind the firewall. So only the request can come in through the application level. So these are the different ways in which the people offer security to the existing application. So only that particular you are only by logging to the computer they can make some changes, something like this sort. So these kind of ways by which security is being actually offered to Elasticsearch. And the last point what you see here is all the data which is being pumped to Elasticsearch undergoes some kind of pre-processing steps. We will understand in detail what are the different pre-processing steps it takes. But in case of traditional MySQL, there is no any pre-processing. Your data is stored as it is. Even if you go and understand in the binary world, your data is stored as it is. There is no pre-processing step. But there are a few kind of pre-processing steps there in the Elasticsearch. We will see in detail about it. Do you have any
Okay.
questions till now in any of this part?
Nothing.
Great. And if you see the like various terminologies of Elasticsearch, you see something called document, index, primary shard, node, cluster, and field. So document is a JSON document, which you might have seen. Let me just pull out some document for you. It's very small. Yeah. Can, can you see here?
Yes.
So this is like a JSON document. A JSON document is like it contains a key value pair, collection of key value pair in a flattened way or in the nested way. Can you see the nested being done? Now we have
Yes.
something called a an object which contains who A and an array. So it can have the nested behavior. So the JSON document is a key value pair which can contain the nested level behavior. It can contain the nested document. So that is a property here, or that's a difference you need to understand. You got it, the clear understanding here, right? What is a JSON document? Someone says
Yes.
a document in Elasticsearch is nothing but the key value pair, okay?
Okay.
And the next part you see is something called index. Index is like a table in relation database. No, this is like kind of wrong. This is like you just have to see it's a database in the whole, not the table. It's a database.
Okay.
Like we create something called create database, right? Similarly, people
Mm-hmm.
create something called index in Elasticsearch. And there's something called primary shard. What's the definition? What I've written here is shard is a single lucene instance. It's a low-level worker unit. What I mean by low-level worker unit is, as we previously discussing about the lucene, I said that Elasticsearch is built on top of Apache lucene. So each lucene instance together form a job and try to form a Elasticsearch node or a instance. So if you see like a shard is like a small low-level worker unit of Apache lucene. That's what they are trying to convey here. So we also
Okay.
discussing about the use case, right? Let's say in a given classroom, if you have like 100, let's say we have like 100 rows, a hypothetical case, if there is only one table to come and read, so there are 100 requests coming to the machine. So all the 100 requests will be processed sequentially. But as we know that MySQL has a concept of partition, so I can divide my data into multiple pieces. I can say that from 1 to 25 you stay, 1 to 20 you stay in this chunk, 20 to 40 you please stay in this chunk, and so on from 80 to 90. So all the 100 people who are coming for retrieving the content from the system, if they know their ID, let's say 1 to 20 go for chunk 1 and 80 to 100 go for chunk 5. See, I can improve my throughput by dividing into multiple pieces, right? Similarly, that's where the shard also works. Shard will try to take the large amount of data and split into small pieces. These small pieces are called a sachet shard. Okay, hope you got it.
Okay. Yeah.
If you see the example, let me complete the node and cluster, then we will again look back the part. So the node is like any instance of Elasticsearch is something is called as a node. Or let I have to rephrase this statement. So any computer or a desktop or a server class machine where you have installed Elasticsearch becomes the node. As simple as
Okay.
that. The cluster is one or more nodes where you have installed Elasticsearch. Together we combine to process some information. Then it forms a cluster. So that is the difference between the node and cluster. A node is a single entity. Cluster is a group of entity. Together it try to accomplish a job. That's a difference. And the third point, what you see is the field. A document contains a list of key and key value pair. Like we saw, right? Name equal to, if you see something called place equal to India, that is where it is something called key value here. Let me
Okay.
zoom out this part. So can you see this picture here? This is like
Yes.
Elasticsearch cluster. What you see, like multiple machines you have here, and your data is divided into three pieces. That's one. The P1 is called the primary part. P0, P1, and P2, and the replication it contains like R0, R1, and R2. Can you see
Okay.
that all the three pieces of my actual data has been split into a different computer? It is not in the same machine. So this is the node 3, node 2, and node 1. Even let's say if I go and destroy the node 3, okay, if I go and destroy node 3, can I able to access all of my data? Is it possible for me? Let's assume that this
Yes.
I completely destroyed this machine. Can I access all my data now?
Yes, you can because you have a copy in other two things.
Yeah, you have the R1 because you have the P1, P2 is there. I have a
Right.
R1 copy, R0 copy here. Still, I can get the complete data. Even if I destroy this machine completely, I have P1, P2, and P0. All my data copies are again available in all the machine. Hope you got right how they design this kind of system.
Yes.
So this is where the sharding algorithm really works. It makes sure that it divides its data into multiple computers or multiple nodes, and it helps you to get the data. That's where it works. And the
Okay.
next thing you have to see here is difference between Elasticsearch and relation database. Whatever we call the database, it's called as an index here. So whatever we call as a table, it's defined as a type, and rows as a document, and column as the field. Hope you are easy to transform from this SQL to Elasticsearch, right? If you start
Yes.
remembering this jargon, it will be very easy for you to migrate from SQL to Elasticsearch. Clear?
Yes.
Okay, now I'll share you the installation guide and I'll also help you with that. Let's look on the architecture. Then let's complete. I help you with the installation also. Can
Mhm.
you see the architecture here? So Elasticsearch is sitting on top of Apache Lucene. Still, Apache Lucene is the fundamental building block. With that building block, you might see something called index and index here. That comes from the Lucene part. And as I said that Lucene doesn't have the clustering ability. Only Elasticsearch has written the clustering ability. So it goes to the cluster and contains the cluster metadata, and all the interface done to the Lucene or the Elasticsearch is done through the call interface or the REST API. So REST API is completely powering the engine. So you might see that this picture might look superficially very simple. It's not like a complete architecture like what we see for other system or a MySQL. If you want to truly understand how the real system would look like, you might have to search with the Lucene architecture. So that might be the right way to understand the system completely. If you search for the Lucene architecture completely, you might see in the picture. Where's the picture? Yeah. This is the right picture explaining the Lucene architecture. Can you see here, right?
Yeah.
Apache Lucene,
Yes.
the core level indexer, text analyzer, text writer, and all the entities what we see as Elasticsearch features, everything resides over here. This is for partially for Solar. So the option what you have to see is the facetting, filtering, the query processing, all the steps is being part of the uh, Apache Lucene. You're clear, right? How it now works?
Yes.
And this is like a simple architecture for the Apache Lucene. You have the corpus. It is being analyzed. Once being analyzed, it's been stored in the index and the searching mechanism. Then it's stored in their own format. This is like the few system design wherein which you see here. This is like a HBase one. We have any questions till now, Makio, on this part?
Nothing. So will you be able to get all these slides with me so that I can
Yeah,
go
I will
through?
be sharing. I just want to collect your email ID. Once you can you share
Uh,
your email ID? So please do me a favor. Can you
yeah.
please download? I also send the download link. Can you please download ES 7.2 and Kibana 7.2? Can you download this version and keep in your machine
Sure. Sure. Sure.
so that we don't
So
waste time on that? Mhm.
yeah, I have a server, so I'll download and keep all the things there
Yeah,
rather than
sure,
in.
that will be great. Okay, great, great, Maggie. Then we will meet tomorrow on the same time. We
Sure.
will tomorrow we will understand the basic installation part. There are like advanced installation and configuration, which is like later part of the course. But tomorrow, what we will see is to get up system up and running, and so that we can start interacting with the system. We don't go in detail about the installation part, but we cover partly to get the job done. So in the later part of
Okay.
the close, like, we will be completely spending our energy to understand how to configure and tweak the system and how to scale in a better way. We will be
Okay.
understanding those areas. Okay.
Okay.
Okay, Matthew. Then see you tomorrow.
Sure. Bye.
Bye bye. So let's get started. So, like, based on your understanding from the internet, what do you think of Elasticsearch on the first and like, what is your understanding on Elasticsearch? What is your thing about Elasticsearch right now?
So I mean, so usually this Elasticsearch, it's like a search engine. and
Okay.
I mean like it responds very quick than the previous tools. So and
Mm-hmm.
also we use I mean like to handle whenever we handle with the big data. So I mean like you have large data and you need to filter or you need to search for it. So we use this tool.
Okay, perfect. So let's get started. Whatever you said is perfectly correct and very valid, and that's what the industry is also expecting. To pick up any tool in the market, the industry folks requires these four important parameters: whether the system is stable, what is the support is there from the community and the documentation, and next is the hardware requirement, how we can scale in a much easier way, and how easy to work with the system. If these four parameters are very satisfied, then your system will or the software will become quite famous. That's the reason like Elasticsearch is like much famous. But I would don't say that the documentation is pretty good, but it's improving over the time. From the versions from 0.x to this point, there is a lot of improvement on the documentation. It's not like a single day like they have done the documentation, it's done and we are good to go. It's not like that. It's a continuous development. Documentation is always a continuous development, which makes the end user to understand the system in a much better way. That's one thing. So let's get started. So here I've just listed like five important points to be considered. Let's go point one by one. Yeah. Let's get started with the first point. The first point speaks about something called real-time distributed search and analytics engine. The first point seems to be very simple, but it contains like lot of information that we have to consider. Let's understand what is a real time first. Then let's try to hop into the other terms. So when I say something called real time, what would be the opposite of a real time? Can you give some examples of opposite of real time? Like you understand what is a real time, right? So we have some information. When the information is available at the very next moment itself, or at the same time, we call it as a real time. Do you agree with me? For example, if I am speaking with you, at the very next moment, you are able to hear me, right?
Yes.
That is something called real time. But if I speak with you over the recorded message, let's say you are not available on your phone, I'm leaving a recorded message to your mobile, but you are listening after a while. Now this becomes something called a non-real time. Do you agree? So we are not
Yes.
able to hear the message at the same time. That is what our traditional post office, all the letters and telegram were working. It is not the real time one. If you send a message to anyone, it will take X amount of time to get delivered, and the recipient has to read at some later point of time. This is the very much similar to the computer systems also. Whenever some data is available at any data source, whether the data is available the next moment or not, if it is available, then system becomes a real time in nature. That's it for point number one. What if you get like a recorded like a Netflix or Amazon Prime, where the movie is being recorded sometime back, but you are viewing it sometime later? That's not real time, right? It's kind of a batch processing. That's why people say something called real time and batch processing. The exact standard terminology verbiage what we are thinking over here is something called real time and a batch processing. Hope you are clear till this point, right?
Yes.
Perfect. Now let's come to the word called distributed search. So I have a job with me. Instead of I compute my job with myself, I am dividing my job across several other people to get the job done. That's what will happen generally in the classroom, right? If we want to get the total of all the mark sheet, if the professor or a teacher issues the mark sheet to the student, if only one person is doing, he will take X amount of time to get the job done. For example, if you are introducing like 10 students altogether to get the job done, so my all my speed to process it becomes like x minus n number of persons who does the operation. If there are five people, so the total number of script is 10 divided by 5. Each person get to do two things. So by less than a minute or so, we will be able to get the result. That's what will happen in generally, right? If you want to increase the speed, that becomes a direct proportion. If you want to increase the building construction speed, the general strategy which builders will follow is they increase the number of workers. So they try to paralyze the number of operations which can be done in parallel. Someone will be working on the breaking it, someone will be doing a plastering. So amount of people who does a job, they try to make it paralyzed, then they get the job done. That's what is happening here. Here they were mentioning of something called real-time distributors. You have some operation to be displayed to the user in real time. For that, like lot of workers or lot of machine working behind the scene to get the result back to the user. Hope you're clear on the first stanza, first point, right?
Yes, Hari.
Okay. The second part is something called analytics engine. That's becomes very critical here. Maybe we have heard the experience of something called SQL, like a different SQL databases which we know comes to our mind is like MySQL, MariaDB, Oracle, IBM, Postgres. These are the list of DBs comes to our mind. They all can store something, but you never heard some information or analytics in me. They can say it can be used to do analytics, but it's not do analytics engine altogether. The reason is the SQL systems are designed are kept in mind on only one thing, which is something called persistence. That's why you get to hear the word called persistence lot with the SQL people. Like you want to store something which doesn't get corrupted or should be atomic in nature. The ACID property. You might heard the ACID property, right? So
Yes.
whenever some data gets stored, it should be stored at any whatever cost is. If there's any transaction taking a bank, whatever the network failure or whatever the failure is happening in the system, either the transaction should happen or not. You should not go to any tri-state. What I'm just meaning here, the tri-state is you should not go and say at the middle point. It should always complete or should not complete. That's the expected behavior of the any system. So your analytics engine here they are trying to describe here is you can do like lot of analytics in the system with the help of Elasticsearch. Like you can do a discovery on the data set of the corpus because this system can speak with big data systems very efficiently, either the Spark or Cassandra, or this itself can work smoothly with any enterprise grade system. So if that is the case, then it becomes more interesting saying that you can do a lot of discovery from that, from the given system. That's why they call it analytics engine over here. The reason, one more reason is like if you compare the number of queries between the SQL and this Elasticsearch, you will be surprised to see that most of the SQL query equivalents are there in Elasticsearch, but there is much more or lot of more functionalities are available than the SQL background. That's the whole idea here. Hope you are clear, right?
Yes, Hari.
Perfect. Now going to the second point is built on Apache lucene. So coming point of Apache lucene is Apache lucene is a Java library. Have you heard about Apache lucene before, Vinod?
Yes, I mean, I heard about that Apache library. Yes, yes. Not exactly
Yeah.
Lucene, but I know about Apache.
Yeah, Apache is a licensing consortium. Like you might have the Apache Hadoop or Apache Cassandra, all this comes under Apache Foundation. So Apache is a foundation wherein which they have like multiple projects below that, which is the Hadoop, Spark, Cassandra, all it comes under the this consortium. So there's something called licensing also. So let's come to that point. Like Apache Lucene is a Java library which is a search engine library altogether. Just understand the word called search engine library. So whenever I just mention the word called library, Java library, only the Java developer can use it. Do you agree with me? Can a Python developer or C# developer can start using the Java library? Is it even possible?
No.
Okay, that becomes a very that's a first bottleneck of any. If you have some library which is written in some language, that becomes a problem because as a non-programming background people or is it a non technology stack cannot even access the library, even though you can claim the library is super efficient. But if you're not able to interface with the system, that becomes a bottleneck. So what the Elasticsearch people did is they wrote a wrapper on top of Apache Lucene and added like lot of functionalities inside the system. After adding the functionality, they gave the interface or the endpoint to the user as the REST interface. So the beauty of the REST interface is it can interact with any programming language in the world. So if you take from C, C++, Java, Scala, Ruby, Python, and Perl, PHP, all language can understand REST API protocol, because REST API protocol indirectly translates something called HTTP protocol. So all the language will ask the facility to interact with this standard definition of standard protocol. That makes system more robust. So any no, programmers or anyone just want to use system, they try to create the REST API interface from the system and connect with Elasticsearch and get the job done. Hope you are clear till this point, right?
Yes, Hari.
Yeah. One more interesting question to ponder upon is something called, what is the difference between the library and a framework? This might be a tricky question. Can you make some educated case like what could be the difference between a library and a framework? Or can you give some examples of a library, some examples of framework? What comes to your mind?
So framework means it includes everything. So includes library and whatever the necessary files required to execute a program. So that
Mhm.
framework contains everything. So library will be like specific. So
Okay.
there could be Apache POI libraries, and there could be some other libraries.
Yeah, true. Can you give example for Apache Perl library? Can you give example for framework? What comes to your mind? Any Java framework?
There are like a Spring, Hibernate.
Yeah, perfect. Okay, now let's try to make it. In a framework, you can start using the library. That's what, well, if you want, if you are using Stack or Hibernate, you can start any point of time. If you want to use some library, it's always obvious that you can just import into your system and start using it. That's the way it works. Now let's try to understand the fundamental difference between the library and a framework. As you said that framework consists of a lot of things behind. It contains all the necessary information. That is perfectly fine. Let's go one level deeper into it. If you start using any framework, if you want to create some class or if you want to do some processing in the given framework, let's say if you want to access a database using the Hibernate, they have specified the standard or the way of interfacing system. We can't do modify, right? They have defined the standard based on the Hibernate people. They have defined standard. Only by that standard you can interface with the system. Do you agree with me?
Yes.
But in case of library, there is no hardened restriction. You can use a library as you want. If you want to use it, initialize it, or if you want to use it anywhere in the system, there is no hardened restriction saying that this is the way by which can use library. That's the first fundamental difference. Framework will try to emphasize or give you a condition or a protocol. This is the protocol you should follow to get the job done. Unlike if you compare with the a library where you can't do much, like library can you are free to use by the your own style. And one more thing with the framework is framework will consist of all the security part, authentication, and all the stuff which will support the ecosystem. But a library will serve only one purpose. That's the whole idea. So few examples of a library, what is there in the market are the following. Elasticsearch is a framework or a system altogether, but there's something called AngularJS, React.js. All these are the frameworks on the JavaScript. But in the same JavaScript, you may have heard something called jQuery and few other like Bootstrap, and all these are called as a library. Now, do you able to distinguish between the library and a framework in a much better way, right?
Yes, Hari.
Perfect. Now let's go to the third point, which we saw something called it all provides a RESTful API access to the system. That's where that point is taken care. And regarding the scalability part comes in two flavor. One is the horizontal scalability, and next is something called vertical scalability. Horizontal scalability is just you try to have like multiple machines in your cluster, which helps you to do the job. But in case of vertical scalability, you have a hardware or you have a laptop. If you want to increase the speed of the machine, you buy extra RAM stick, or if you try to upgrade the processor, you can do the upgradation. But there's a catch. You can't keep on upgrading for a given hardware. There's always a limitation. Let's say if you are increasing like 64 GB to your like a laptop, maybe after that point you can't even really think about increasing your memory to your machine. Do you agree with me, right? That is one of the important problem with the vertical scalability. You can't grow as you think. But in case of horizontal deployment, as and when if you want to increase the load of the system, or if you want to cater the larger amount of people, it's very easy that you just deploy the lot of small machine in the cloud and they get the job done. Hope you are clear now, right? What is the difference between horizontal and vertical scalability? Now the fourth point is it's an open source platform. Like you get to access the source code, you can try to modify the source code, and you can also ship the same. That's the whole point. You don't have to pay any price for it. That's another advantage of the open source software. And next is something called schema free. So people coming from the, you are aware of the SQL concepts, right?
Yes.
Okay. People are using this SQL system, like if they want to insert any data into the system, first they what they do is they try to create a database. After creating the database, they try to create a table with a table definition. Create table name student with the name, age, and address. All the individual column will have the respective data types, whether it's the varchar or age or integer, will have the respective field information. From that, what happens is if you are inserting it, all the data will be conforming to that standard. But in case of Elasticsearch, you don't have to specify the key schema in upfront. Whenever you index or insert some data into Elasticsearch, system automatically infers like what is the data type for the given field. Hope you are clear right till this point.
Yes.
System can automatically infer the type of the data what you are inserting. This feature is something called auto inference in Python. If you take a programming language like Python, you don't have to specify what is the data type. Let's say if you just say a equal to 5, then system automatically identifies that this belongs to a type of integer. If you say name equal to hello world, now it can type find it to a string. But in case of Java, it's always mandates that you have to give a data type before you declare a variable. Let's say string name equal to hello world. Only if you give by the data type in upfront before the variable name, it can accept. That's the two important thing. Likewise, system automatically infers the type from the system from the data whatever you insert. Hope you are clear, right?
Yeah, it's clear.
Okay. Now it all comes under the family of document database. Like no, it comes in the family of NoSQL. NoSQL has three different types. One is the key value, document based, and they have something called graph. So this comes under family of document based. Document based nothing but is a JSON document style, nothing more. Hope you are clear, right? Other
Yes.
examples of the document based database are the Couchbase, and you have something called CouchDB, MongoDB. All these are examples of the document based database. Hope you are clear till this point, right?
Yes.
Let's try to understand who are the people are using Elasticsearch. These are the people are using it: LinkedIn, Facebook, Netflix, Quora, Wikipedia, Stack Exchange. These are the list of people who are using Elasticsearch as the backend engine. They are using it at one point of another. Which system or which platform you are using it more often, Vinod?
So that website you're talking about website, maybe like Facebook.
Yeah, in Facebook, I'm just saying that the Elasticsearch is being used. Can you guess or find what is a feature where they are using in Facebook? Can you think of that where they are using it in Facebook?
Yeah, maybe when you want to search for the people names, there we can use this Elasticsearch.
Yeah, perfect. Let's say if you start some typing some information, what happens is as you start typing it, you are getting suggestion right, which is nothing but autocomplete feature. If you are doing any search by entering the query string, bulk indexing part. I never taught you on the bulk indexing part last time, right? But I just showed you the difference in speed, right? Did I show you difference in speed, like doing the sequential one and the bulk index one? Did I show that back you?
No.
Okay, great. Then I should show you the first. That will be my first part. Once done, is it clear for you, or is it very small still?
It's a little small, so if you can zoom it a little more, then it will be clear.
Okay, maybe I'll just pull out for. How is now?
Yeah, it's better now.
Okay. So the fundamental difference what we are going to see today is to do the what is the difference between the sequential indexing and bulk indexing. So if someone says something called sequential and something called a bulk or a batch update, so what is the difference you think between both will be there? So what comes to your mind? Someone says a sequential and a batch.
So sequential, if it goes for the SQL thing, one by one it will update. Let's say we have a 10 update statement. It will update the first one and then it will commit. It will go for the second and then it will commit. And if it is a batch one, it will take a group and it will commit at one time. I mean, after completing everything, it will commit at once.
Yeah, perfect. So as you are a database, as you have experience in database, what do you think is a right for a database? A sequential or a batch? What do you prefer generally?
It depends on the situation. If we have a huge amount of thing, we'll go for batch because in between, if some error happened, it will not commit the entire thing.
Okay. So if you have like huge number of things, you said you will go for bulk or a sequential.
Bulk one.
Okay. And when you choose the sequential one, what is the constraint you will choose sequential?
Sequential, I'll choose if we have very less amount of data which is stored inside the DB table.
Okay, fair enough. So, like being a DBA, you know the number of connection pool a database can have, right? So, if you just
Right,
open and see a database, the active connection, what the database or system can have, it actually varies in a great extent. That's
right,
a different story altogether, right? In my case of
right,
MySQL, the default connection would be like 8 or 10, if I'm not wrong, something of that sort. Maybe for other data, active connection. I'm not speaking about the concurrent parallel connection. I'm just speaking about the active connections are allowed in the system. So as we know that the only 8 connections are allowed by default in nature. If we want to have a better connection rate in MySQL, then definitely we have to increase the size in the config file. Then we will proceed further, right? That's why we
correct,
operate in general, because as we know that each connection creates a thread. Which actually creates like lot of resource or a lot of content in the system, because if you, we can't say that I can parallelly increase my connection request to 100 or 1000. It definitely has an impact on the database system. Similarly, like the main part why they try to yeah, have a control limit on the connection part is what is Elasticsearch, the difference between the search engine and database, and what is the point you would pick up the search engine or database, and what is a constraint that you will choose this kind of technology stack, when should you choose and when you should not choose the technology stack. Then we understand the various terminologies, the jargons what people are using in Elasticsearch. Then the installation of Elasticsearch, how to install standalone in our computer. I will help you with the instruction part. Then we will go and understand the architecture of the system, how the system is being built on the whole of the top. We will be having a complete understanding of the big picture. That's the whole idea of today's class.
Okay.
Victoria, do you have any laptop? You have a laptop with you, right?
Yes.
So can you let me know what is the spec of your laptop? Then let's start then. So what is Elasticsearch on the first hand? So if you see from the 5 bulleted points, what I mentioned in this slide is like you will see the different features what Elasticsearch offers to its users. Like they have some fancy word called real-time distributed search and built top on lucene, RESTful API, open source and document base. We will try to understand point by point, and then we will take up from that point. We will try to go from that point. So you have some word called real-time distributed and analytics engine. So that's where we have to understand what is something called real-time systems. If you are from computer science major or if you are working in a company, there are like two kind of systems generally available in the market: real-time and non-real-time systems. The real-time systems are systems where they attach the sensors. Like if you have any temperature sensors attached to a machine, that machine has to record the data continuously from that sensor and have to send a feedback to the user. So all the data being collected from the system, it's real time and will be processed in a real time. That's what the people calls the real time system. And the traditional non-critical real time system or system where the criticality is not very important. The criticality remains a very huge impact in case of medical instruments. If you are trying to measure the blood pressure or some critical like ECG, it should be real time. If it comes like 10 minutes delay or 15 minutes delay, it doesn't make any sense for us. It should be a real time, because whenever we record any medical instrument, we have to get the value in real time, at least by not less than zero point 0.5 seconds. That's what the real-time system really meant is. And what is they are trying to mean here, something called real-time distributed is, let's say you have a system wherein which you can divide your work among multiple machine. From that multiple machine, as you divide a work across all the multiple machine, you get the work from all different machine, then you process that and you then display to the user. That's where you have something called real-time distributed search. That's what they are trying to mean here. Let's say like, maybe let's take an example of a distribution. Let's say government is distributing the maybe a ration card, or maybe a voter ID, maybe ID for some kind of a purpose. If there is only one signal person who's distributing the work or distributing among the people, he may take X amount of time to give the ID to n different user. What if government employs like multiple persons to do the job? Definitely there's a reduce in timing, right? So each can take like a set of IDs with them, then they can go sector by sector, then they can distribute to the people across living in that area. So my work to time to complete my works reduced by half. Do you agree with me till that point, Victoria?
Yes.
Okay. Now, if you directly translate the same logic to computer, I have like n number of computers with me. What if I can distribute my workload or my efficiency, not the efficiency, or my workload or the power to drive the system across n number of people? Then certainly it doesn't take n time to get processed. So if I have more resource in my system, definitely my response time is better. Here the response time, what I'm trying to say here is my search experience or the time to get the document. It improves significantly. That's the key factor here. Like these concepts actually come from the word called something called scalability. There are like two kind of scalability the systems are. One is the horizontal and one is the vertical. Let me just pull out some picture for the horizontal and the vertical part. Can you see this picture?
Yes, I can.
So if you see, like I was discussing on the scalability part, right? Traditionally, computer science people or the computer science architect or in any enterprise, they do scale to increase the workload by two means. One is the vertical and one is the horizontal part. The vertical part is like you are, sorry.
No, continue.
Yeah, sure. So the vertical part is, let's say you have a laptop with you. Currently, you have a CPU of you have a CPU of i3. Let's say if you want to upgrade to i5 or i7, definitely you can do that. Still, you can increase your RAM from 4 GB to 8 GB or even 16 GB. And similarly, your hard disk space also can be increased from 1 TB to 2 TB if you have a sufficient amount of a hardware resource. But if I say that, can you keep on increasing your laptop specification? That is not possible. The reason is the hardware constraint. The board or the motherboard can handle this much of CPU, or it can handle only, it can have only a certain constraint on the improving or upgradation part. but this is on the vertical scalability. Earlier people were used to do the vertical scalability. If they want a higher performance, they increase your CPU cores, or they try to increase your CPU RAM. That's why they tried doing earlier. But what happens from the year of 2000 or 2010, the concept of NoSQL came in. The NoSQL mean here is not only SQL. By beating the traditional system, then now their design is, I have like multiple machines in my office or the server. I will install individual pieces, or I'll distribute my workload across all this machine. Then I retrieve back my search result. This analogy, like that's what we discussed some time back. In case of government wants to distribute an ID to the people, instead of one person doing that, I am allocating 10 resources or 10 persons to do the job, so I can get my work in much more faster way. That's what the key idea here lies in. So now you understood, right, what is a vertical scalability and what is a horizontal scalability. Hello.
Hello, can you please take that again?
Sorry.
Can you take the difference again, horizontal and vertical scaling?
I'm not able to hear your voice clearly, Victoria. Can you be a bit louder, or something mic problem is there?
Hello, I said, can you please take the difference again between the two?
Sure. The vertical scalability is you keep on adding your hardware capability to the same machine. Let's say you have a laptop with you. In that given laptop, if you start upgrading your RAM or a CPU, if you want to upgrade from i3 to i5, or if you keep on adding to a resource to one particular machine, that is called as a vertical scalability. If in the same case, if I have like multiple machines or a multiple laptop or a desktop, I spread my work across these machines, and then if I get data from that machine back, that is called as a horizontal scalability. Are you with me now?
Okay, yes,
Are you clear?
I do now. And I can see the picture, yes.
Yeah, great. So this is the another example. Can you see here? See, in this case, the vertical scalability, one CPU, 1 GB RAM is like they say $10 per month. They say 2 GB $20 and 4 GB is $80 per month, which is the cloud environment. Similarly, in the horizontal scalability, they are using the same machine. So if they are trying to use like 4 CPU machine. Now see, with the help of 4 CPU machine itself, they are trying to bridge the same effect. Can you see here? That's where the horizontal scalability comes to the play. Now you got right?
Okay.
Great. So then there is something concept called analytics engine here. The analytics engine is like you can do like lot of data analytics operations on the data using Elasticsearch. You can try to get like what is the count and what is the number of document being processed, or what is the maximum number of transaction, what is the highest where. So you can query the system to get whatever insights you are looking for. So the querying, with the help of a querying part, you can interact with the system and get the data back. That's where the Elasticsearch. Then you have something called Apache Lucene. It's built on Apache Lucene. Apache Lucene is basically a library. On top of that library, Elasticsearch people wrote a wrapper, or a kind of a small abstraction wrapper. From that, they try to develop or made some advanced feature on top of Apache Lucene. Then they got data from that. Then they could develop the system. That's where the Apache Lucene comes here, and it says that it scales easily as it supports like a horizontal scalability. So I can divide my work into multiple machines, and the access to the machine comes from the forms using the RESTful API. What I meant by RESTful API is, let's say I develop a application programming language called X, or even let's call it as a Java. If I develop something in Java, only a similar application in Java can interact with the system. Other application, if you ask them to interact, they have to follow a different strategy. Let's say Python program, if you want to interact with the Java, it's not possible directly, because Python works in a different way and Java works in different way. So but what Elasticsearch people have designed is they created a platform wherein which all the interfacing happens through the REST API. REST API is a technology or a kind of a concept wherein which the system interacts through the backend using the HTTP protocol, hypertext transfer protocol. Through that, we are able to interact with the system. So the REST API interface is common for many programming languages in the world. Even it starts from C, C++ to advanced language like a Java and Python. So all programming language can seamlessly interact with the REST API protocol so that this system becomes language agnostic, which is like any system available in the market. You can call Python, Java, C++, C Sharp. Any system can interact directly with Elasticsearch without much effort. That's the key idea here. And the fourth point, what we are discussing is it's completely open source. What I mean by open source is you can go to github.com, then you can get the complete source code of how Elasticsearch is completely built. From that, we can understand that how the system is built, and you can modify your source code according to your wish. So if you are modifying your source code, similarly, you have to also publish in the open source platform. That's what the license actually speaks here. So you can completely customize the Elasticsearch in case if you want to need, but you have to have like a professional development team to do the job. That's where it starts here, and it's all goes from something comes in a family of document based. Have you heard about NoSQL, Victoria? Any chance before? NoSQL. Hello, Victoria. Can you hear me?
Yes, I can hear you.
Have you any chance? Have you heard of something called NoSQL database?
I've heard of, yes, SQL and NoSQL data.
Yeah, great. So if you heard about the SQL database in the market, you have mentioned about the MySQL and MariaDB or MS SQL, Microsoft's database server. If you go to the NoSQL family, you have like a 4 different kind of database, which is the column family, the graph, document based, and a key value pair. Okay, these are the 4 different families what is there available in the market in the current day. So the database family what we are discussing belongs to Elasticsearch belongs to something called document based. That's the idea what I want to enforce here. Do you have any questions or doubt at this point, Victoria?
Hello, what did you say?
You have any questions
Hello?
or doubt?
Yes, the thing is, are we doing a recording of this session?
This session is recorded. You can contact Mind Magics to get the recorded session.
Okay, so I can get the recording. Okay, okay, because I'll probably need to like listen to it again to really digest all that you are saying.
Okay. If you find my accent is very hard, please let me know. Okay.
Okay, okay, I'll let you know.
Sure.
What happens when you knock it off?
So now let's understand who are the people actually using Elasticsearch. Almost all famous websites in the world like Stack Overflow, Facebook, Wikipedia, Mozilla, Netflix, all major companies around the world are using Elasticsearch to power their search operation or to facilitate the searching operation in this system. So almost all major companies are using around the world. Victoria, have
Okay,
you
can you
used Stack?
please, okay,
Sorry?
can you please give an example of what, like, maybe let's use, is Amazon there? No, like what, how Netflix uses Elasticsearch? Can you please explain?
Sure, definitely. I'm glad to explain that. If you have used Netflix before, you might have searched for the movie name, right?
Yes.
Do you provide complete movie name when you give a search, or you give a partial movie name?
Sometimes I give partial movie names or like partial the one of the lead actor or something name.
Yeah, yeah. What you answered actually as a question. So most of the time, or the most of the user does not know the complete name of the movie. That's the most reality. Most of the only the famous movie. if we have something in our mind, we will give a complete movie name. In general, most of the time, we might search with the director name or the lead actor, or we search by the partial movie name which comes to our mind. In case if you are giving a partial search, how do you think in the back end Netflix is able to power or able to retrieve the movie list from their catalog? The movie searching catalog itself is being powered by Elasticsearch. So whenever you search something called Jurassic Park, the Jurassic Park itself contains like several parts, part 1, part 2 and part 3. So on searching something called Jurassic Park, if you are able to get all the 3 parts, then we are actually more successful, right? If the user wants to have like a more final control, let's say he just says Jurassic Park 1, then his result is being sorted to the top. Now the Jurassic Park 1, the result will be displayed on the top, and the 2 would be displayed at the second, and 3 would be displayed at the third. Do you agree with me? Hello?
Yes, I do.
Yeah. So have you ever wondered how those kind of search operations is able to perform, or how is performed? Everything is performed using Elasticsearch. Or if you might use the Google search engine, if I search for a thing called Africa, I'm just doing a random one. Let's see what is the answer I'm just getting here. The first article is displayed to me is the Wikipedia article, and the second article it just shows me the Britannia, which is the Wikipedia one, the older Wikipedia, and it goes for the some news channel. CNN goes for the CNN channel. But if you open your Google Chrome or if you do a Google operation, do you think you will also get the same result in your machine? The search result would be actually varied between you and me, because your search is kind of more different than my search. Do you agree with me? Can you give a search on your machine and try to see what is the result you're getting on your laptop?
Okay, I should do any search.
Yeah, you do a search on the country, the keyword called Africa.
Africa. Africa. I can see, well, the first one is just showing like a map,
Okay,
and
then
the other one, Wikipedia, and then flags of different countries in Africa.
okay, that is your option you're
And
getting,
then,
right?
huh?
Okay, so now do you agree what I have searched in my computer and what you are searching for the same keyword? We are both having a different results. Do you agree with me?
Yes, we are having different results. Yes. Why is that?
Yeah. So that is called something called relevance, or something would be more relevant. So the results being obtained based on your search experience. Based on your search experience, system have given preference that if this user is searching for Africa, then his intention or what she or he is expecting something is very different. Being I am from a different country, when I do a search, my result, what I displayed is something very different, right? So that's where we see something called relevance. Something might be more relevant for you, or the article would be more relevant for you. Some article would be more relevant for me. So do you see here, right? There's a small difference here. This is and all the place where Elasticsearch is extensively used. Are you clear?
Yes.
And
Okay, so with
another example.
Elasticsearch, all search will reveal the same thing.
Yes, exactly. If you start using Elasticsearch to query a document, you can also build a similar search engine like this. That's the key idea here.
Okay, that makes sense.
And if you have opened Wikipedia any chance before, if you just open here and if you have typed something on the search button, can you see the search bar here, right? on the top right.
Yes, on Wikipedia, yes.
If I search something called maybe NA, can you see here, right? My search result has been auto-completed. It can be a Narendra
Yes.
Modi, it can be a National Football League, it can be National Register of Historic and Nazi name Germany. So with I'm typing partial word or a character, I'm able to extrapolate and then able to get the document name right. This is also a feature in Elasticsearch, which is they call as autocomplete. This feature name they call as
Okay,
autocomplete.
yes.
Autocomplete is you type something partial. Now system is able to get enough information as you start typing. If I type NAB, now the document relevant to the NAB is actually displayed here. That's this is again a feature of Elasticsearch. That's why the Wikipedia is using the system. Now you understand, right, where Wikipedia is used as a system and how it uses.
System. Okay. So
Great,
now I get it.
perfect. Now let's understand the difference between a search engine and a database. What I meant by a search engine here is Elasticsearch is a search engine. The reason why I'm giving a name called search engine is, like as we discussed few minutes back, we saw example for Africa, right? You are getting a
Yes.
different result and I'm getting a different result based out of some rank. These kind of system can be developed using Elasticsearch. That's why they call as a search engine here. If you go and type what a search engine in Google, the what result would be displayed is it is an information retrieval system. What that means is you can search something from the system and you get relevant information in some ranking order. That is the big whole idea here. Okay, that is where it comes in. That's why the Elasticsearch is called as a search engine. Now let's compare Elasticsearch or a search engine with the traditional database. That's where we are trying to understand the difference. The search engine, the main reason it is being designed is for the search. Like if the user want to search something, the key fundamental idea for a design system like Elasticsearch is for the searching operation. But in case of like a traditional database system, the main purpose of the design is for the persistence or for the general purpose. CRUD stands for create, read, update and delete. It stands for the create, read, update and delete. That's what it stands for. And the it's designed for the general purpose. The second point is search engine heavily operates on text data. Like if you want to understand what are the text data, then you might have to ask a question: what are the different data formats which I have in the available market, or the different data format? One is the image, video, text file, and binary file. These are the general classification of the file format. Now, the search engine are designed to leverage or improvise the performance of any text search document. Let's say you have any Facebook comment. We are not sure that what is the length of the comment, right? If I post some document, if I post some information in Facebook, my friends can type two-line comment or my friends can type one-line comment. Either of it is possible. In that case, what I am trying to say that if the document contains like a lot of textual information, then Elasticsearch is the right candidate to pick and work. In case of database, it operates on rows and columns. That's the difference here. And the third important difference, what we have to understand here is, it search engine works on algorithm called TF-IDF, term frequency, inverse document frequency. Just for the names, you don't have to understand much on this part, algorithm part. We will understand later part. And the next part is it provide database works on algorithm called B tree. If you Google what is a B tree and what is TF and IDF algorithm, you will get a lot of information on those topics. That will give you like a better insight on that. The fourth part is Elasticsearch by default doesn't offer you the security and transaction like a SQL system. Anyone with having access to the computer can modify the system without any effort.
But if you use any traditional system like SQL, user has to enter the username and password. Only when the username and password is correct, he or she would be given a complete access to a system. Till that point, user can't access system. Do you agree with me?
Okay, but okay, yes.
And the last point to understand here is data is pre-processed before indexing. Here, when we say some data to be inserted into Elasticsearch, people you will use a name called indexing. The term indexing actually came from a normal colloquial term called index. If you open any book, you would have an index or a table of content, right? So that will contain the page number and the chapter description. Or if you open the end of your book, there will be like a bibliography, wherein which it will indicate that where each document is present. Let's say if you open and understand what is a word called computer, if the computer that system or that book speaks about computer, it'll give you like listing or places where my word called computer is being listed. That is where the pre-processing is being done. In case of a traditional system, there is no such pre-processing technique. Data is stored as it is without any effort here. You are clear to this point?
Yes, it is fine. So Elastic is a search engine, right? Or a database?
It's a search engine.
It's a search engine, okay.
And going forward, now let's understand what are the different terminologies and jargons used in Elasticsearch, or the concepts what we call in colloquial terms. The document, index, primary shard, node, cluster, and field. These are the words you will be keep on or often being repeated when you start understanding or start using the system. You will be hearing this word very often. Now let's understand what is a document in general. Have you heard about JSON document before, Victoria?
Yes, but I don't know
So
what it
if
is.
you, yeah, if you open and see any JSON document, let's say maybe let's have this document. It has the key and a value. It says that hey guy, and the number is something here, and the object, and you have something awesome is true and bogus equal to false. Now the JSON document is constructed using something called key value, collection of key value in a nested form. It creates a JSON document. The system also, the document in Elasticsearch also accepts the JSON document only. So whenever you want to insert something, it has to be a JSON document for sure. That's the whole idea here. Then the next point, what you see here is the index. The index is nothing but like a table in the database. Sorry, the database in the table in the database system. So let's see in the upcoming part, and you see something called primary shard. The primary shard is a piece where you store the actual data. Let's say if you have like 1,000 records, all the 1,000 record if it's stored in a shard called A, that becomes the primary copy, or that is the parent copy of that. If you have something called parent copy, then there will be have something called child copy or a mirror copy. So that mirror copy is something called as a replica. Now that replica will have the same copy as a parent copy, but in a different computer. In case one machine goes for off or there's some network kind of a damage or issue, other system can jump into the system, or other system can start using the backup server. That's where the sharding concept comes here. Are you clear?
Okay, you can continue.
Sure.
Sure.
And you have something called node. Node is nothing but if you install Elasticsearch in your laptop, then it becomes Elasticsearch node. Very simple as that. If anywhere you
It
install
becomes Elastic.
sorry,
If I start Elasticsearch on my computer, you said it becomes what?
it becomes node.
Node, okay.
In case if you have a multiple laptop in your home or a multiple computer in the office, if you install Elasticsearch in each and every machine, then it becomes cluster, because Now these group of computer together try to form a common name, the cluster name. Now that cluster becomes your operation. Now you understood what is a cluster, right?
Yes, I do. A collection of nodes.
Exactly, yes. Then you have something called field. That field contains a list of, like as we discussed earlier in the JSON document, this is called as a field, key and a value, or a field and a field name. That's why they call that something called node. Can you see this picture?
Yes.
The picture
Node
what I'm
master.
yeah. Let's say this is your laptop 1, node 1. Laptop 2 is something called node 2, and you have something called laptop 3 as a node 3. Now if you see here, my data has been split into 3 pieces. The primary data, P1 stands for primary shard. Now the primary shard is divided into 3 different chunks. P1,
Hello?
yes. Hello.
You can continue.
Yeah. If you see here, my data is divided into 3 different pieces, which is something called P0, P1, and P2. Now all these divided pieces are left in 3 different nodes, laptop 1, laptop 2, and laptop 3. And you also have the replication thing, R0, R1, and R2. So now we have the primary copy here and replication copy. What if this node doesn't work? Now, do you think whether this operation can collect all the data? Let's say if the node 3 doesn't work for a hard disk failure or OS gets corrupted, can you able to retrieve all the information for the given piece? Is it possible?
What did you say?
I was explaining you that let's say you have like 100 records or 200 records with you, okay?
Okay.
If you divide your data into 3 different pieces, now it becomes like 50, 50, 50, 50. Let's assume that you have like a document count of 150, 150. Now if you try to divide into 3 different pieces, P0, P1, and P2, each contains 50 documents. Are you with me till now?
Yes, I am.
If I have like data in 3 different node, I'm also having like 3 different copy of the same data. Now the P0 data will be replicated in the node R0, P1 will be replicated in R1, and P2 will be replicated in R2. Are you clear till this point?
Yes, I am.
Now, what I was saying earlier is, what if the machine 3 or laptop 3 does not work for some reason? From the given system, can you able to collect all the 150 records? Is it possible?
Yes, it's possible because it's been replicated.
Yes, that's the key idea here. The replication factor plays a vital role in providing the failover, and it provides you redundancy. Clear? So we completed the chapter 1. Chapter 2 we completed, and chapter 3 we understood the bulk, the Python integration with Elasticsearch. Then we understood about the Kibana part, like what are the various part and the how to query the document and how to retrieve it. And we also saw about the plugin development in Kibana. These are the various content we saw. And the fifth important part, what we're going to see today is the searching part. Like this is like the part where the user will start to query the Elasticsearch to get some content out of it. Okay, so this is like the like already we saw like a few queries like the create, read, update, and delete. So now we will understand about how things works in Elasticsearch, the other set of APIs which makes Elasticsearch even more powerful and even stronger, like the different features we will look into it. And for our next part, we will see is the aggregation. The aggregation is for the analytics purpose. If you want to do some analytics on the data which is present in Elasticsearch, then the aggregation query is the right candidate for it. So it's supposed like out of the box solution for most of the case. And then we understand about how it affects the scoring and scoring part in Elasticsearch. These are the various part we will look into in that part. Okay.
Okay.
Just give me a
So we are
minute,
going to
Victoria.
do.
Yeah, just give me a minute. I just have to make a call. I'll just come back. Sorry, Victoria, you were saying something. What is it?
Hello.
Yeah, I can hear you. You were saying something right before I was about to leave.
I
What is
said
it?
we should. I said I would really like to learn more about aggregation parts because I work a lot with analytics.
Come again. Sorry, I lost your voice.
Hold on. Hello.
Yes.
You mentioned aggregations for analytics.
So you want to say you are trying to convey that you want to more emphasize on aggregations part, right?
Yes.
Perfect. Yeah, we'll look into it. No worries on that, Victoria. We'll just jump into that. Okay. Materials. The query DSL. So hope you remember this part, right? The different features of Elasticsearch, what we explained in the first class, real time and distributed in nature. With those are the features we were understanding some time back, right? And the searching operation. So it all boils down from the mapping part, Victoria. So you remember what is a mapping, right? So what we do is we try to create the schema for a document. What is the type of it, whether it's an integer or a float or a string. So we try to define the mapping. From the mapping, it divides into two different parts. One is the analysis and the query DSL. So today we'll be looking on the query DSL part. So as I said earlier, the DSL stands for domain specific language. So like instead of SQL, they call it as a structured query language. Here they say it's something called domain specific language. You have to understand why they call it a domain specific language on the first hand. Like if you take any system, like the system like the user where they speak in their own terms. Let's say you are a healthcare specialist. Why should I expect you to know these SQL? If you the verbiage and the terms, if it is very similar to your domain knowledge or your domain experience, that will help user to work in a much easier fashion, right? Do you agree with me? Hello.
I didn't get what you said.
So I
Hello.
was, uh, if you are working with any system, if the query is more specific to your word or the terms what you use in your day-to-day
Can you
life,
hear me now?
I can hear you. Can you hear me now?
Yes, I can hear you now.
Okay. So what I was saying now is, like, let's say you are a healthcare professional. I'm just assuming that you are a healthcare professional. if your query or the language what you're gonna interact with the Elasticsearch, if it is much similar to your term what you use in your day-to-day life, then writing a query becomes much simpler, right? Do you agree with me?
Yes.
So that is what the DSL tends to focus on. So it will try to make sure that user can write queries so easily. That's the main intention. Coming back, the general query in the system comes from the two different parts. One is the queries and another is called a filters. Okay. Let us understand what is query on the first hand, and let's understand what is a filter. By chance, do you have any knowledge on SQL? A little bit of understanding on SQL by chance, Victoria? Any chance?
If I understand queries,
Yeah, SQL, structured query language, the database, the MySQL.
I just started
Sorry?
learning SQL.
Okay,
I only
okay, no
started
problem.
learning SQL recently, so I just have like
Okay.
basic idea.
Okay, great. So let me make in a simple terms. The filters are the exact match. If you have a Excel, if you go and filter saying that age equal to or age is greater than 15, we apply the filters in the Excel sheet, right? The general filters what we apply on day-to-day life in the Excel spreadsheet. That is the actual filter. So the filter will try to emphasize whether it matches the given condition or not. It will look for exact values. What you see is the exact value. If it matches the exact value, then it proceeds. Then all the results are cached. You understand what is a cache, right?
Yes, like a
And this
temporary storage.
Yes, right. So, and it's much faster. So the filter component of Elasticsearch works on this fashion. It is faster and is cacheable, and it can look for exact values and works on the Boolean mode, yes or no, true or false condition. If you come for the querying part, now the emphasis comes here. Results are not cached, and it's slower, and it's a full text search. So there is a two kind of fields in Elasticsearch. Just to understand the holistic level, there are like two important kind of text fields available in Elasticsearch. One is the keyword, and one is the text. You read about the text and keyword anywhere, Victoria, before?
I
Hello.
think so, yes.
Yes,
Hello?
great. Yeah. I'll just give a small intro about the text and keyword. I'll just open the part for the text and for the keyword. Can you read out what is they are mentioned here, Victoria, for the text part?
A field to index full text value, such as the body of an email.
Can
These
you
fields are
understand from
analyzed.
Yeah, proceed. I'll explain you once you're done with it.
Okay. Okay. So we are saying that text are not used for sorting. Like you can do a full text search, you can use it for searching, but it's not used for aggregation. Okay, I kind of understand it.
Yeah, so the example what I like to present here is if you are using the Google Drive or Gmail, if you want to search any specific mail from your inbox, which we tend to do, right? We might have sent a mail sometime back. We may not know entirely the content by heart, but we know just bit and pieces of the content in the email. We go to the Gmail box and we give the query and we start collecting some information, right? That's what people do it, right? So you supply some small information for the whole corpus. From that, system can infer or can search and provide you the result. You understand, right? That is what the text field does for you. Are you clear till this point?
Can you please repeat it again?
Sure. Let me just give you the demo. That would be better. I'm just opening my Gmail box, okay? Okay. I should open the other account. Okay, I'm just looking the keyword here.
Yes.
Can you read it down?
If it's an index structured context, that's email address that typically used for filtering for certain applications. Yes, fields are only searchable by their exact value. Okay. I think at the initial stage, when we started, as an after indexing a document, it will ask you for like the data types you want to use as keyword, right?
Yes, right.
I think we did that at the initial stage.
So what they are trying to compare here is, if you have a string in your document or any content, what you're going to index into Elasticsearch, now string can either take a text field or it can take a keyword. If it have specifies a keyword, you have to give the exact match. Understand? I'm just using the word called exact match. Only if you provide the exact match, it can retrieve the content for you. If there is no exact match, then it is hard for you to, it is not allowed. That's kind of completely banned. You have to give the exact match to get the content. But if you see the other way, like the what is it called, the text part, that text field, even if you supply the partial keyword in the document, it is searchable. That is the whole idea here. I hope you are clear, right? If you want to
Yes.
search the content in a document, then you have to use the word called text. A text keyword, you have to use it. If you want to go for the exact match, then you may have to choose with the keyword. Can you see the examples here, right? The status code, the zip code, the tags, those are the keyword fields what they are mentioning in the document. If you look for the text data type, the very thing they say is the body of an email, because we just have to always, we are searching for we just know some content in the body of the email we are trying to search. Similarly, if you are opening up any Amazon or a Flipkart or any product recommend product site, you provide with the product description. You just say that black color T-shirt or black color shirt. That's the item you provide. The shirt might be had a name called polo or crocodile, but if you are trying to use a word called black shirt, now it goes and searches in the product description and returns back the result. I hope you are clear with the example, right?
Yes.
Great. That's what the queries works on the text field, Victoria, while the filters works on the keyword. That's the whole idea. Hope you are clear till this point, right?
Yes.
Perfect. Now the first and foremost query what people used to do is the get underscore search. Now let me spin up the instance. It started. Now let's go to the browser. Okay, I'm just opening the dev tools. Let's take the example of mapping ELK. That's the traditional one which we know. Get mapping.elk. Can you see what is displayed on the right hand side? Can you see here, Victoria?
Yes, integer text, float text, integer.
Float. You see the different the types what we have mentioned here, right? Everything is a text or a float or whatever we call it. It comes over here. Okay. So the first and foremost query what we tend to do is we just use a word called underscore search, which we are doing for a very long time. On doing this, if you use the plain underscore search, you remember, right? I said the default number of document displayed to the user on giving underscore search is 10. You remember the first class I mentioned, right? Only the
Yes.
top 10 results, not even top, the 10 results will be displayed to the user. If you want more record, the option would be like adding the field call size or the column call size. If I just specify 20, then 20 records return back to the user. See, if I want to retrieve 100 documents, so basically, I'm able to retrieve the 100 number of documents what I like to retrieve back from the system by using your using the field call size. You are clear to this point, right? That is the
Yes.
first one. And if you carefully notice, I'll just go to the top. If you carefully notice, can you see something called score here?
Yes.
Everywhere if you see the score, everywhere it comes around 1.0 constantly
What
because
does it
the
mean?
yeah, that's a good question. What is score really meant here? The score is some kind of a number which will indicate that how much this document is relevant for you. Let's do by this way. If I search with the Nigeria and if I say something called food, I'm just using the same word. I have been displayed with this website, Africa Tourism Travel Log 23 Nigerian food. So it gives me like a Wikipedia comes in this part. If you do the search in your computer, there's a high chance or there's a chance that you can have a different result. Do you agree with me? Your result and my results will be always different. Do you agree on that point?
Yes.
Can you say why it is different for you and me? Because I am searching the word called Nigeria food. Why you are getting a different result and why I'm getting a different result? Have you ever thought why is it so?
I think they probably use a lot of information to display any information that is relevant to you.
Yeah. Now you used a word called which is relevant for me. You came with the word called relevant for me, right? So the system uses lot of data to understand or give a feedback which will be more relevant for me or you. So basically, try to give a personalized recommendation to the user. Do you agree with that? How that's what the Google really works in general.
Yes.
So it understands a lot of data and decides like what to be more appropriate for you. That is the big picture here. Coming back to the story, if you see something called score equal to 1, if it says that all the document are given equal weightage, means indicates that this document is not inferior to the document ID 2 or document ID 2 is not inferior to document ID 1. All the document has the same ranking feature. Okay, that is the whole notion. We will understand one by one. But till now, you understood what is the concept revolves around, right?
Yes.
Perfect. The second part, what we're gonna do is to understand something called match field. Okay. If you carefully notice, I just use the same word, but I'm just using the type called match with the title and my content. Let me go through this part in the Kibana here. I'm just using the word called get mapping.elk stat underscore search query match and it requests me to provide the user field of my choice. Now the field of my choice is the name. Okay, I'm just want to select the name. I'm providing the name over here. I'm just selecting the word called Harris, the partial word. On doing that, it says that it returned the document which has like a count of 15. Okay, it returned the document which has the condition word called Harris, not the complete name. You understand? I'm just giving my partial name here. You see the difference here, right? I'm not giving the exact name here. I'm just giving the partial name what I get from the system. Can you see the score here now?
It has changed to 5.7.
5.7. If I go to the second result, still it remains as 5.7. 5.7 and goes on. I think everything. Yeah, can you see here?
It has reduced to 5.1.
Yeah, now score starts to decrease as you go on. If I tend to have a different word, maybe let's say a Henry. If I go with a word called Henry, now my maximum score is like 3.7. My next document is also 3.7. It goes on. And you see here the document score is reduced, right? So it tries to basically replicates what Google search engine does for you. It gives the importance for each word in a document based on an algorithm called TF-IDF. You remember the algorithm I used to mention in the first class, right? So now this algorithm will give you a score. Based on that score, your result would be sorted and provided to the user. That's the bigger idea here. Can you see here, right? If you just open and understand what is being written here, in information retrieval, TF-IDF algorithm, the short for term frequency, inverse document frequency, is a numerical statistic that intend to reflect how important a word to a document in a collection of corpus. When you do a search, it basically decides that how much important the document for the given space, and it is often referred as a weighting factor in a searches like text mining and user modeling. So like what Google does in a very fundamental ways, kind of using the TF-IDF to get the part. And you see here, right, one of the simplest ranking functions computer using TF-IDF for each query, and more complicated are ranking are a variant of the simple model. So you understand, right, what is happening now. Can you see the word called relevance here? The variation
Yes.
of TF is often used in search engine as a central tool in scoring. The word scoring is being used, and ranking is also used for a given user query. The user query what we gave earlier is the term called Henry, right? That's a query what we are searching in a system. And it says that a given query and its various subject field including the classification. It decides, okay, based on the number it gives you some score. From that score, your document has been ranked order. If this higher rank, then you are returned back to the user with the result. That's the key idea here. Hope you are clear to this point, right?
Yes.
Great. That's the match query now. Now you understood what is a match query would look like. And there is something called match all. Without any filter condition, you are trying to search for the all the document. Again, if you notice here, all the document would be given a equal weightage here in the match all clause. Query match all. On doing this, you see here, right, all the document will be given an equal score equal to 1111. All the document would be given an equal score. It's something like regular to underscore search, nothing fancy here. The next query what we'll be doing is on the match phrase. Let me just pull up the match phrase here. Get slash mapping.elk underscore search query. You see something called match phrase, right? Now I'm gonna search with the phrase word. Now I'm using the same word called name. Now I'm just searching for the document which matches this phrase, the two words altogether. Still, I'm not giving the complete one, but I'm giving a phrase altogether. Match phrase. Is the field name correct? Okay. The name should be a caps here. Do you see here, right? Now it is returns a rank by giving the maximum score is level 11.5.93 and returns a document which matches the condition. So it has like 4 different matches for the given query, like ALDA ACLM. So it returns me the result saying that it all matches the thing. So now we are giving like two words which combines to from the phrase over here. That's the match phrase. Now the third part is get mapping ELK underscore search query match paste prefix. Now the match paste prefix will try to emphasize that if you give some prefix to your search, like you should have the content in before. That's the key idea here. Basically, if you just give the hint saying that let's search with the word called Azir. Now the document consists of the word called Nazir is being displayed back to the user. Can you see here, right? If let's search for the Misters. Now it matches like 387 document which has the word called Misters and returns you the result back. Like what are the document it matches with the word called Misters here. And if you let's say if you want to search with the word called maybe let's pick it up with the dot or a Carolyn or let's use the word called base from. So now I'm just giving the prefix part. So whatever you should have the prefix content than the suffix part. Like what I'm mentioning here is now if you just say based on Mr. it should be in the prefix part. Only if the prefix matches, the second part would be retrieved back. Even if the order is different, if I just interchange this order, now this doesn't work because you have mentioned that the prefix this works by the prefix part. You understand, right, how the match based prefix works. Now the prefix will try to emphasize saying that ordering is very important. Hope you're clear to this point, right? Early in this case, if you interchange and run, it will work. If I go and change on the match phrase, now it returns me the 3 result. Even if I rerun and run it, let's see what happens now. Now the match phrase doesn't match a given condition, but again, if I just give the word called asim or adl, it is able to still return the result. The prefix will try to emphasize a condition, or you can use some partial word. Let's say the base from. See, I'm able to give a partial word here. I'm not even giving a complete word. I'm just giving partial word. I'm just keep on reducing. I'm just getting byst. Now you see it right. See here, right? I'm able to get a smaller subset. I can give like HEN. Now what are the name it match with the HEN just matched here. Can you see here, right? Henry, Henwick. Can you understand, right? How is that? How it understand how it relates? Hope you're clear to this point, right?
Yes.
Great. So this is with the scoring part. So that's the first level. That's the part like the algorithm they are saying here, how the algorithm works. I'll just explain the algorithm in a simpler fashion. Maybe I'll just like pull out. Yeah. Here when they mentioned right the full text search query, match query, multi-match, common query, simple query. The thing what we have to look here is on this part, the different term level queries. Terms, range, match, prefix, these are the different variants what you see in the system. Can you see the term query here, right? If you want to search in a specific field or only a single field, you can use something called term. If you want to search a given query in a multiple field, then you can provide the terms, which is the plural part of the term here. Just add the S here. If you let's say if you want to search for a product which contains a black shirt, now it should search on the product name as well as in the product description. So that during that time you will use something called term query on that. And what about the range query? If you are searching for the ages like age greater than 10 and less than 40, you are doing a range comparison, right? So for that range comparison, you will use the range query here. The second part, the exist part, it whether checks whether the document is exist in the system or not. The prefix part, like what is like we are saw the prefix query, right? How the document should be prefixed in the wildcard. Even if I just go and give the star, it should work out of the box. If I just say Henry star, let's see how it works. See now it can start to understand the star pattern. Look, while all it can able to see the Henry and followed by star, it starts to does the regular expression scan for you. Hope you're clear to this point, right?
So if you use star, that is acting like the wildcard search. It will bring up every word that starts with HEN, right?
Yes, you are right. That's a wildcard search. You are right. Clear till this point, Victoria, here, right?
Yes.
There is also a regex query. Wildcard will support like one or two normal operator. But if you go for regex query, now you can define like complex use case on the regex part. Still, you can go as complex as possible. That's on the regex part. Have you worked with regex regular expression before, Victoria?
No.
Okay. This is like a glorified or the more detailed way of the wildcard search. It's also a wildcard search, but you can do much more than in the regex query. That's the part I'm coming to emphasize here. Clear, right?
He said it will do much more than wildcard.
Yes, you are true. Yes. I'll just show you some example how the regular expression query really works in. You will be surprised to see that how complex or how simple you can make your life much more simpler way. If I have a name, Hari Ganesh. So can you see here, right? In this document, I have a two email IDs here. One is my email ID and one is something like very similar to yours. And I have free float text and I have a number, okay? If I want to match all the digits over here, can you guess what could be the way to extract all the numbers from the given text? Can you think what can be done?
You call for like integers or something.
You see what I'm trying to do? It might sound like Greek and Latin, but it's way simpler. I'm using something called \d and using a plus. So can you see here, right? Now my numbers are matched over here.
Okay.
Only my numbers are matched. If I want to match only the email ID, I don't want to match these two content. I'm using /w, which is the word, and using the operator /w /dot. Can you see what is happening now here, right?
Yes.
So I'm able to, from a given corpus, I'm still effectively able to retrieve only the email ID from the document. I'm not searching the other space. My email ID is exactly pulled out from the document. Can you see the beauty here, right? I didn't write any complex code to write the extract the email. I wrote simple code, simple regular expression pattern, which can extract the content from the system. You are able to appreciate the power of the regular expression, right? That's what I said. It is much more powerful. If you go and type /star, now all the that's what you do it in the regular expression, right? If I just say Victoria star, if I use Victoria star or dot star, can you see here, right? With this entity, I'm able to search the entire email ID from your corpus. Can you see here, right, how it's done?
Yes.
Hope you can understand why I said it's much more powerful, right?
Yes, because it's easier to search.
Exactly. You just give a try on learning regular expression, Victoria. It will be much powerful for your day-to-day activity. You will be surprised to see that how automatically or how effectively you can do your job if you know the regular expression. It's more powerful than what we think. Okay.
So the today's agenda would be like we will be discussing on the Elasticsearch CRUD API. What I mean by the CRUD API here is the create, read, update, and delete. So traditionally in SQL system, we used to do the stuff right, the create
Right,
command,
right.
delete. Similarly, we also be discussing those things here. And the main concern or the main thing you have to notice here is every the interaction with the system is all through the REST API. You remember, right? I
Okay.
was saying that
Yes.
Elastic made the abstraction saying that everything would become the REST API. Here are all the interaction of the system is through the REST API only. That's one thing.
No.
So if you faintly remember, there are like 10 to 15 important verbs or the actions in the REST APIs. The get
Okay.
command, post command, delete. You remember any of those things? Have you heard about that?
Yes, yes.
The get and post call, just to get the idea here. So you will have the get command, post command, delete, and the put command. So these are the different commands we might have heard some time back. These are the commands through which we will be interacting with Elasticsearch directly. So let's
Okay.
jump into the part and try to get it. So install the Kibana and Elasticsearch in your server machine, right? Just a
Yes,
minute.
yes.
Hello. So we just have to pull that. So let's get that. So the first command to get the create the index is using the put command, which will create an index. Before that, let's use the traditional command get underscore cat indices. So this command is equivalent to show database command. Hope you remember, right?
Yes, yes.
That's something called the show database command. On do firing this query, we will get the list of indexes present here. As I said last time, the databases are called as index. So the command to retrieve the content is something called get underscore cat slash indices. That's the command we used to fire to get the indexes available. in the system. That's what to get it. And the now let's try to create a sample index. So the index name itself sample, I'm just using something called sample index. On firing this, on my right hand side, if you carefully notice here is, it says that acknowledge equal to true and short acknowledge is also true and index is sample index. So it acknowledge, let's verify whether it's been created using the cat command again. On firing the cat command again, can you see here? Sample index
Yes,
is being created here. So this
yes.
indicates that document has been created and the index is being created, but still we didn't create any document inside it. Using like a create database command, it will be like empty, right? Empty, right? With empty without any tables. Similarly, it is also empty here. Nothing happens here. The next step, what we have to understand is we have to create some document out of it. So let's create a document, some sample document, sample index slash underscore doc, which is the type name. I'm giving one as my document ID. For my easy access, I'm just giving my document ID. I'm just giving name equal to India. Okay. And let's say like what is it I can say? Color is equal to maybe blue. Come on. So on firing this command, the post command, see I'm able to get the result here, or it gives me automatically saying that on the right hand side. It says that the index with the name of sample index and type is underscore doc, and ID with the version ID, so type 1, the ID number, and gets me all the content result equal to created and shard equal to total and successful equal to 1. You don't need to understand what is there in the second part, but you understood the first part, right? To create an
Yes.
index, we are using some command called put, which is like creating some resource or modifying some resource in the server. That's what the put command used to signify as. The second part, what you see here on the post command here is, it tries to create some sample document for our working purpose, or to create some, like we used to do in the create table command, create insert table, right? It's something very
Mm-hmm.
similar to the insert table. In this example, what we did is we created index first and then we created the document. It is not mandatory that we have to create the index first to begin our work. What we can do directly is I'm just creating the sample index 2 and my doc /1. I'm just copy pasting this exact content. See, I never had something called sample index 2 on, you can also verify here. There is something called sample index is only there. There's nothing called sample index 2. But on firing the post command itself, it says that I'm able to create the index as well as the document at the same time. There is no hardbound restriction like we do have in SQL, right? We have to create the
Oh,
table, we have to create the database and table, then the content. It is not mandatory like that. We can create the index and the document on the fly. There is no restriction here. And the important concept what we have to cherish here is, I never specify what is the data type of the name or the color. You are seeing here, right? I never specified as a string or a varchar. It is understood by the default. You are understanding the key critical
yes.
difference, right?
Good. Good.
Right. So we understood how to create the index and how to create a document. And
Right.
one more small variant here is, like till this point we are able to create the document with our own ID, maybe a document ID 1 and 2 or a generic ID. It is not required for us to provide the document ID every time. It can automatically create its own ID. I'm just removing this ID and I'm firing it here. And if you carefully notice here, this point, it says that my document ID is something very large, kind of a very hash number. Can you see here?
Yes.
Yeah, this is the hash number internally created by the Elasticsearch, but it's kind of a recommended practice that instead of you giving the document ID, if you allow Elasticsearch to itself to design the ID, it will be much more efficient. Because losing ID creation itself kind of a science behind the scene. Just give me a minute. I'm
Okay.
just getting a call from the water supply. Just give me a minute. Ma? Sorry about it.
That's okay.
Yeah. So you don't have to create your own ID. Elasticsearch or the Lucene itself can infer the ID on its own. That's
Hey,
the beauty. Sorry.
I can't see anything. The screen sharing is gone. Oh yeah,
Screen is
it
gone.
came up. Yeah, it came up.
Okay. So
So
can you see the? Sorry, Mackie. Please
the,
proceed.
Yeah, the ID means that is a name of that particular document, or is it something like the name of the table?
I would say the ID is the row ID, what we have in SQL, right? Kind of a primary key.
Okay. Okay. Got it.
Kind of primary key, it is not like order sequential. Or if you might have worked with something called UID in MS SQL. Have you heard of something called UID in my MS SQL?
No, I didn't work with MS or anything. I mean, I'm just
UID
about.
in just say MS SQL, they generated a it's also there in MySQL. Actually, the in the recent version they have introduced it. UID is something like kind of a unique ID, like a other number. They generate something that's very unique here. Can you see the number here?
Okay,
Kind of a,
got it.
something of this sort. So this
Okay.
ID helps us to decide or helps us to distinguish the other documents in the system. It's kind of a row ID, nothing fancy here. But this
Mhm.
document ID has some significance in making it in a better way. Let me change to maybe like a green. So now the command what I'm going to do is something like a select star command what we used to do in SQL, right? Something like
Right.
using a command because we are not doing any operation, we just retrieving the content, get sample index 2 slash underscore search. On doing this command is something very similar to the select star. Can you see the result here?
Yes.
Okay. So the document what we created with the document ID 1 is also existing with India and blue. And second document what we tried to create this, it's also with India blue, but it's on the own document ID. Third document ID is India and green. This is the last update what we made. Now it has two document ID. I said right there is a small significance in getting the ID. Let me just paste in a better large screen.
Mm.
And this is it. Can you see some difference here?
Yeah, only the last part. 1, 2, 3, 4. Last four letters are having no. No, it's starting with okay.
The first four and the last four only actually changes in both of the document. Can you see here?
Right.
The first four and last four actually has it one significance. That's why I said right. Elasticsearch internally has some understanding of the document itself, like how it is like a combination of your timestamp, what timestamp the document is created. That's one thing, and second,
Mhm.
it consists of where the document itself located. It has some internal meaning. I just want you to take that point. That's the key
Okay.
fundamental idea here. Okay.
Uh-huh.
And when we start going inside the Elasticsearch folder, let's go into the folder and let's go into the data folder. Can you see the folders here?
Yes.
I'll just in a better way. If you carefully observe the document, if you fire again the get indices command, if you compare the documents here, can you see some similarity here? With this ID over here, can you see some similarity? Maybe I'll just pick up the XQ. Maybe let me zoom it before. Can I see it now? Is it fine for
Yes.
you?
Yes. Yeah.
Maybe let's find the sample index 2. Where's the sample index 2? TWSSX. That's the word we have, right?
Right.
So let's see where's the TW. Yeah, can you see here?
Yes.
So the document ID, what we are going to create here, it has its own ID. So there's this command we have, right? There's a one more variant of this command using question mark and V. On applying question mark and V, you will get something called a detail message with the heading.
Okay.
Can you see now? Earlier, we never had a heading with these kind of details. It says that health, status, the index name, and UUID, the universal identifier, and the primary and the replica, the docs count, doc deleted, storage size, and primary storage size, etc. These many details you have right.
Mm-hmm.
You have any questions till now? You are good to your flow, right?
Yeah.
Great. So on the health part, if you notice here, you have something called yellow and you see something called green, right?
Mm.
So just for a side note, health actually indicates that how is the shard is really performing in the system. There are like three kind of health indicators in Elasticsearch, which is something called red, yellow, and green. Green indicates that everything works fine out of the box, no problem, no trouble. Yellow
Okay.
indicates that there is some kind of problem or there is some kind of issue. Still, I have not failed yet, but there is a warning. I'm approaching failure. That's what it indicates for the yellow status. And
Okay.
the red status clearly indicates that I can't really work anything out of it. There's some big problem. Only if you correct, I can make some steps further. That's the indication it provides here. But if you notice here, the sample index 2, what we create itself contains the yellow status, right?
Yeah. Yes.
So can you just think out of the box, what could be the reason for it being yellow? Because we never did anything here, nothing fancy, just like two documents we have with the name and color, like two document field. What could be the reason here?
Mm. No idea.
Okay. So you remember the primary shard and the replica shard, right? What we
Yes.
discussed in the first. Hope you remember, right? Can you
Uh-huh.
just give a difference between the primary shard and the secondary replica shard, if you can recollect some points?
Primary shard is the one which is where we are storing the data, and secondary shard is the one which we are backing up the docs, if I'm not wrong.
Yeah, perfect. That's like kind of a perfect one. Adding to your point, like the primary shard itself will be divided into multiple pieces. You remember, right? We have something called shard one,
Correct.
shard two, shard three, because to have the redundancy, have the better redundancy, and for a failover condition, we divide it into multiple pieces. And similarly, for the secondary shard or the replica shard, also will contain the same information. If you notice here, I never specified what is my primary shard count and replica shard count. I never specified what is my replication factor, or I never specified what is my size of my chunk. We never did anywhere, right? So these
Right.
important thing what you have to understand is Elasticsearch by default provides you the two basic configuration by the default configuration, which is that primary shard count is one and replica shard count is always one. Okay.
Okay.
If
Okay.
you notice here, can you see on the PRA and the REP column?
Yes.
So it clearly indicates the number of primary thing is one and the replication is one. And you remember, right? I also said something important on the first class saying that you can't create the replica in the same shard. You remember, right? In the same machine, I
Yes.
can't create a replica. What is the point of creating the replica in the same machine? As in this system, we don't have any secondary server attached here because the standalone installation. I don't have any another laptop or another node in my cluster or in my network. So it says that I can't create a replica shard. That's why it indicates saying that I'm still in the yellow status. But if you
Okay.
carefully notice the yellow column, green column, you will see small difference. Can you find the what is a small difference here?
Yeah, the replica is 0.
Yeah, being replica 0, it is able to satisfy the system constraint and it is in green status. Nothing to worry. As the default
Okay.
configuration indicates, the replica should be 0. Now we don't have any trouble in using it. Now can you correlate, right, how it has been done?
Okay. So how to make this replica 0? Do we have to do some configuration changes in?
Yes, that's a question I was expecting from you. So the question, what the way you can do is, let's create another sample index here, maybe sample index 3. And if I say, Put sample index 3. I'm just creating index now to provide the configuration. Not mapping, it's on the replica. 1 second. I'm just have to take the what is the command. 1 second. Yeah, I need to use something for settings. Slash settings. Now I'm going for the configuration mode. If I type something called index or replication itself, can you see here? I'm
Yes.
just turning it off to 0. Okay, it says that no index found. Maybe let's do it for the sample index 2 itself. We are trying to reconfigure it. Okay, it's done. Now let's go and query the system here. Can you see how what happened now?
Okay.
So both the primary shard count and the replica level can be modified according to your need.
Okay.
So by default, it actually provides you with the one. But if you want to have like number of primary shard is equal to 3 or 4, which you can configure during your index creation, and the
Okay.
replication factor can be updated dynamically. That's the beauty here. Let's say we
Okay.
started with the 0, we started with 1, we can change to 0. That is allowed. But what is the catch here is we can't do similarly for the shard because once the data is divided, it's hard for me to reconcile, right? So the only
Right.
that option can be done on the beginning. You can't modify now and then. That's a small difference. You are
Okay.
clear, right?
Yes.
So things what and all we gone through is we understood the query to get all the documents or all the databases present in the system using the cat indices command. That's one thing we done. The second command what we gone through is select star using the get and the index name and applying underscore search. We are able to get all the documents for the given index. That's the second one. And the third
Right.
one, we are able to create the index separately using the put command. Then the next step is using the post command, which allows to create the document inside the given index. Either we can do with the document ID, which is like a user defined, or we can allow the system to pick up the document ID on its own. So we also understood that okay, if the document ID is if you allow the system to allow to pick it up the same ID on its own, we see some kind of pattern. That's the only thing we have to know right now. We will be discussing how the UID is actually making a big impact in the cluster level. So that's one thing.
Okay.
We also open and saw the data folder, how the data folder actually resides here. Okay. And the
Okay.
last part what we are discussing on the cluster status. We are discussing on the cluster status, indicating that there are like a three different things: the red, yellow, and green. And we also understood what makes it yellow or the green part. You are clear to this
Okay.
point, right?
Yes. And this UUID, that ID what we are giving, can we give it as a number or any kind of data type, right?
Is for the document level, or you are saying on the index level?
No, document level. That number what you have given one. Instead of one, I can give some name or something, right?
Yes, you can.
Okay.
Let us say, see, it's able to do it. Let's query and get it. Can you see here the
Okay.
NA part?
Yeah.
for computers, basically like alphanumeric or fully numeric, it all sees as a binary, right? So it doesn't make any big problem for you because this thing itself like alphanumeric. Can you see here, right? This itself like
Yes.
alphanumeric. Then it means that we can give like name of any name what comes to your mind, the name of the alphanumeric values. That is possible. And one more thing to notice here, we discussed about the health and we know what's the index name and we understood what is the UID. This UID is a unique ID which is used to distinguish the folder in the Elasticsearch level. That's one thing. And we know what's the primary and the replication. And one thing we don't notice here is on the status. It says something called open, right?
Right.
So what would be the opposite of open here?
Closed.
Yeah. So the main difference what you have to understand here is when they say some document or index is open, which means it's ready for search. You can also turn off an index for the closed status. Now you all of a sudden you might strike a question. Why they are opening and closing document? Why don't they destroy completely? That is a like kind of very valid question. But let me introduce you some your better use case. Let's say you have a company, telecom company, you are recording your call information record for over like past 1 year, okay? That is your requirement. Let's say suppose you want to maintain only last 30 days of information. Other details you can store it in some data lake or data warehouse. That is like a better use case control. But your manager come and says that no, you just hold your data for last 6 months, but make the data only available to the user for only 1 month. In this case, what you can do to make the user to available only 1 month is you can restrict in the query level, right? So you can make sure
Right.
that query doesn't go exceed the 1 month. That's a one level of control you can do. But the better way of control what you can do with the system is you can close the index itself, which is like turning off the engine. Like you let's say you have like 3 to 4 bikes in your home, you don't want a bike to be actively used because when you turn on a bike it consumes petrol and it consumes battery, which is like a CPU and the RAM usage. If you turn off any of your bike, it goes to the idle state, right? It's basically it's turned off, but still it
Right.
is there in the system or still it's there in your home. Nothing changes till this point. In the can you relate that kind of functionality here, right? Here, right? Similarly, close is also a kind of functionality which will help you to turn off the given index whatever you have. You can explicitly turn off your index. And let's turn off the index and try to see what happens now. Put sample index to close once again. Yeah, clear this till this point, Matthew, right?
Yes. Yes.
Great. It says acknowledge equal to true. Let's go and query the document and see whether how it comes now. Can you see here?
Yes. Close.
It is closed completely. If I go and query the command, which is like getting the all the document, see what is the error you get here.
Disclosed as an exception. Okay.
So it clearly indicates that I can't work with the given index. It's already turned off. So something like you can't bike engine because the key is actually missing, something of that sort. You can try to reconnect with that example. You're clear till this point, right?
Yes. And in future, if you want, we can open it again, right?
Yes, we just have to change to close to open. That's it.
Okay.
If you open, again it comes for the search. Yes, we got it. Clear, right?
Yes. Yes.
And the important thing why this can be applied is like generally during like a time series log indexing system, most of the people will standard practice it. They try to create the index on daily basis. Let's say you have an index something called Airtel. I'm just creating a hypothetical case. Airtel day 1 of the January 1, January 2. They will start with the prefix called Airtel and the division name hyphen Jan 1, something like the sort. And Airtel division name and Jan 2. Similarly, you might, if you trying to run the system for 365 days, you will have all the details for a given day in each of the index. That's a standard practice people would follow. In certain situation, it might require like a hourly basis, or in such situation, it might even require you on minute basis, depending upon your workload. Okay. So like if you are going on the every day, if you start to create an index, then you can turn off your index like whichever which is very fast for you. With the help of a date itself, you can go and turn it off, right? We don't generally this feature would be mostly used where they try to create the index on the daily basis, because then only then it makes sense, right? If I go and entirely turn off, there is no specific point. Let's say you're operating for last 6 months in a single index. If I go and turn it off, my last 1 month data I can't really get out of it. Only if you try to have like a modular approach, you really can make a better out of it. You're clear to this point, right?
So we completed the chapter 1. Chapter 2 we completed, and chapter 3 we understood the bulk, the Python integration with Elasticsearch. Then we understood about the Kibana part, like what are the various part and the how to query the document and how to retrieve it. And we also saw about the plugin development in Kibana. These are the various content we saw. And the fifth important part, what we're going to see today is the searching part. Like this is like the part where the user will start to query the Elasticsearch to get some content out of it. Okay, so this is like the like already we saw like a few queries like the create, read, update, and delete. So now we will understand about how things works in Elasticsearch, the other set of APIs which makes Elasticsearch even more powerful and even stronger, like the different features we will look into it. And for our next part, we will see is the aggregation. The aggregation is for the analytics purpose. If we want to do some analytics on the data which is present in Elasticsearch, then the aggregation query is the right candidate for it. So it's supposed like out of the box solution for most of the case. And then we understand about how it affects the scoring and scoring part in Elasticsearch. These are the various part we will look into in that part. Okay.
Okay.
Just give me a
So we are
minute,
going to
Victor. Yeah, just give me a minute. I just have to make a call. I'll just come back. Sorry, Victor, you were saying something. What is it?
Hello.
Yeah, I can hear you. You are saying something right before I was about to leave.
I
What is
said we
it?
should focus. I said I would really like to learn more about application parts because I work a lot with analytics.
Come again. Sorry, I lost your voice.
Hold on. Hello.
Yes.
You mentioned aggregations for analytics.
So you want to say, you are trying to convey that you want to more emphasize on aggregations part, right?
Yes.
Perfect. Yeah, we'll look into it. No worries on that, Victoria. We'll just jump into that. Okay. Materials, the query DSL. So hope you remember this part, right? The different features of Elasticsearch, what we explained in the first class, real-time and distributed in nature. With those are the features we were understanding some time back, right? And the searching operation. So it all boils down from the mapping part, Victoria. So you remember what is a mapping, right? So what we do is we try to create the schema for a document. What is the type of it, whether it's an integer or a float or a string. So we try to define the mapping. From the mapping, it divides into two different parts. One is the analysis and the query DSL. So today we'll be looking on the query DSL part. So as I said earlier, the DSL stands for domain specific language. So like instead of SQL, they call it as a structured query language. Here they say it's something called domain specific language. You have to understand why they call it a domain specific language on the first hand. Like if you take any system, like the system like the user where they speak in their own terms. Let's say you are a healthcare specialist, why should I expect you to know these SQL if you the verbiage and the terms, if it is very similar to your domain knowledge or your domain experience, that will help user to work in a much easier fashion, right? Do you agree with me? Hello.
I didn't get what you said.
So I
Hello?
was, uh, if you are working with any system, if the query is more specific to your word or the terms what you use in your day-to-day
Can you
life,
hear me now?
I can hear you. Can you hear me now?
Yes, I can hear you now.
Okay. So what I was saying now is, like, let's say you are a healthcare professional. I'm just assuming that you are a healthcare professional. If your query or the language, what you're gonna interact with the Elasticsearch, if it is much similar to your term, what you use in your day-to-day life, then writing a query becomes much simpler, right? Do you agree with me?
Yes.
So that is what the DSL tends to focus on. So it will try to make sure that user can write queries so easily. That's the main intention. Coming back, the general query in the system comes from the two different parts. One is the queries and another is called a filters. Okay. Let us understand what is query on the first hand and let's understand what is a filter. By chance, do you have any knowledge on SQL? A little bit of understanding on SQL by chance, Victoria? Any chance?
If I understand queries,
Yeah, SQL, structured query language, the database, the MySQL.
I just started
Sorry?
learning SQL.
Okay,
I only
okay, no
started
problem.
learning SQL recently, so I just have like
Okay.
basic idea.
Okay, great. So let me make in a simple terms. The filters are the exact match. If you have a Excel, if you go and filter saying that age equal to or age is greater than 15, we apply the filters in the Excel sheet, right? The general filters what we apply on day-to-day life in the Excel spreadsheet. That is the actual filter. So the filter will try to emphasize whether it matches the given condition or not. It will look for exact values. What you see is the exact value. If it matches the exact value, then it proceeds. Then all the results are cached. You understand what is a cache, right?
Yes, like a
And it's
temporary storage.
Yes, right. So, and it's much faster. So the filter component of Elasticsearch works on this fashion. It is faster and is cacheable and it can look for exact values and works on the Boolean mode, yes or no, true or false condition. If you come for the querying part, now the emphasis comes here. Results are not cached, and it's slower, and it's a full text search. So there is a two kind of fields in Elasticsearch. Just to understand the holistic level, there are like two important kind of text fields available in Elasticsearch. One is the keyword, and one is the text. You read about the text and keyword anywhere, Victoria, before? Hello.
I think so, yes. Hello?
Yes, great. Yeah. I'll just give a small intro about the text and keyword. I'll just open the part for the text and for the keyword. Can you read out what is they have mentioned here, Victoria, for the text part?
A field to index full text value, such as the body of an email.
Can you understand?
Analyzed.
Yeah. Proceed. I'll explain you once you're done with it.
Okay. Okay, so we are saying that text are not used for sorting. Like you can do a full text search, you can use it for searching, but it's not used for aggregation. Okay, I kind of understand it.
Yeah, so the example what I like to present here is if you are using the Google Drive or Gmail, if you want to search any specific mail from your inbox, which we tend to do, right? We might have sent a mail some time back. We may not know entirely the content by heart, but we know just bit and pieces of the content in the email. We go to the Gmail box and we give the query and we start collecting some information, right? That's what people do it, right? So you supply some small information for the whole corpus. From that, system can infer or can search and provide you the result. You understand, right? That is what the text field does for you. Are you clear till this point?
Can you please repeat it again?
Sure. Let me just give you the demo. That would be better. I'm just opening my Gmail box, okay? Okay. I should open the other account. Okay, I'm just looking the keyword here.
Yes.
Can you read it down?
If it's an index structured context, such as email addresses, that typically used for filtering for sorting and applications. These fields are only searchable by the exact value. Okay, I think at the initial stage, when we started, as an after indexing the document, it will ask you for like the data types you want to use as keyword, right?
Yes, right.
I think we did that at the initial stage.
So what they are trying to compare here is if you have a string in your document or any content, what you're going to index into Elasticsearch, now string can either take a text field or it can take a keyword. If it have specified a keyword, you have to give the exact match. Understand? I'm just using a word called exact match. Only if you provide the exact match, it can retrieve the content for you. If there is no exact match, then it is hard for you to, it is not allowed. That's kind of completely banned. You have to give the exact match to get the content. But if you see the other way, like the what is it called, the text part, that text field, even if you supply the partial keyword in the document, it is searchable. That is the whole idea here. I hope you are clear, right? If you want to
Yes.
search the content in a document, then you have to use the word called text. A text keyword, you have to use it. If you want to go for the exact match, then you may have to choose with the keyword. Can you see the examples here, right? The status code, the zip code, the tags, those are the keyword fields what they are mentioning in the document. If you look for the text data type, the very thing they say is the body of an email, because we just have to always we are searching for we just know some content in the body of the email we are trying to search. Similarly, if you are opening up any Amazon or a Flipkart or any product recommend product site, you provide with the product description. You just say that black color T-shirt or black color shirt. That's the item you provide. The shirt might be had a name called polo or crocodile, but if you are trying to use a word called black shirt, now it goes and searches in the product description and returns back the result. I hope you are clear with the example, right?
Yes.
Great. That's what the queries works on the text field, Victoria, while the filters works on the keyword. That's the whole idea. Hope you are clear till this point, right?
Yes.
Perfect. Now the first and foremost query what people used to do is the get underscore search. Now let me spin up the instance. It started. Now let's go to the browser. Okay, I'm just opening the dev tools. Let's take the example of mapping ELK. That's the traditional one which we know. Get mapping.elk. Can you see what is displayed on the right hand side? Can you see here, Victoria?
Yes. Integer text, float text, integer.
Float. You see the different the types what we have mentioned here, right? Everything is a text or a float or whatever we call it. It comes over here. Okay. So the first and foremost query what we tend to do is we just use a word called underscore search, which we are doing for a very long time. On doing this, if you use the plain underscore search, you remember, right? I said the default number of document displayed to the user on giving underscore search is 10. You remember the first class I mentioned, right? Only
Yes.
the top 10 results, not even top, the 10 results will be displayed to the user. If you want more record, the option would be like adding the field called size or the column called size. If I just specify 20, then 20 records return back to the user. See, if I want to retrieve 100 documents, so basically, I'm able to retrieve the 100 number of documents what I like to retrieve back from the system by using your using the field called size. You are clear to this point, right? That is the
Yes.
first one. And if you carefully notice, I'll just go to the top. If you carefully notice, can you see something called score here?
Yes.
Everywhere if you see the score, it everywhere it comes around 1.0 constantly,
What
because
does it
the
mean?
yeah, that's a good question. What is score really meant here? The score is some kind of a number which will indicate that how much this document is relevant for you. Let's do by this way. If I search with the Nigeria and if I say something called food, I'm just using the same word. I have been displayed with this website, Africa Tourism Travel Log 23 Nigerian food. So it gives me like a Wikipedia comes in this part. If you do the search in your computer, there's a high chance or there's a chance that you can have a different result. Do you agree with me? Your result and my results will be always different. Do you agree on that point?
Yes.
Can you say why it is different for you and me? Because I am searching the word called Nigeria food. Why you are getting a different result and why I'm getting a different result? Have you ever thought why is it so?
I think they probably use a lot of information to display any information that is relevant to you.
Yeah. Now you used a word called which is relevant for me. You came with the word called relevant for me, right? So the system uses lot of data to understand or give a feedback which will be more relevant for me or you. So basically try to give a personalized recommendation to the user. Do you agree with that? How that's what the Google really works in general.
Yes.
So it understands a lot of data and decides like what will be more appropriate for you. That is the big picture here. Coming back to the story, if you see something called score equal to 1, if it says that all the document are given equal weightage, means indicates that this document is not inferior to the document ID2 or document ID2 is not inferior to document ID1. All the document has the same ranking feature. Okay, that is the whole notion. We will understand one by one. But till now, you understood what is the concept revolves around, right?
Yes.
Perfect. The second part, what we're gonna do is to understand something called match field. Okay. If you carefully notice, I just use the same word, but I'm just using the type called match with the title and my content. Let me go through this part in the Kibana here. I'm just using the word called get mapping.elk stat underscore search query match, and it requests me to provide the user field of my choice. Now the field of my choice is the name. Okay, I'm just want to select the name. I'm providing the name over here. I'm just selecting the word called Harris, the partial word. On doing that, it says that it returned the document which has like a count of 15. Okay, it returned the document which has the condition word called Harris, not the complete name. You understand? I'm just giving my partial name here. You see the difference here, right? I'm not giving the exact name here. I'm just giving the partial name what I get from the system. Can you see the score here now?
It has changed to 5.7.
5.7. If I go to the second result, still it remains as 5.7. 5.7 and goes on. I think everything. Yeah. Can you see here?
It has reduced to 5.1.
Yeah. Now score starts to decrease as you go on. If I tend to have a different word, maybe let's say a Henry. If I go with a word called Henry, now my maximum score is like 3.7. My next document is also 3.7. It goes on. And you see here the document score is reduced, right? So it tries to basically replicates what Google search engine does for you. It gives the importance for each word in a document based on an algorithm called TF-IDF. You remember the algorithm I used to mention in the first class, right? So now this algorithm will give you a score. Based on that score, your result would be sorted and provided to the user. That's the bigger idea here. Can you see here, right? If you just open and understand what is being written here, in information retrieval, TF-IDF algorithm, the short for term frequency, inverse document frequency, is a numerical statistic that intend to reflect how important a word to a document in a collection of corpus. When you do a search, it basically decides that how much important the document for the given space. And it is often referred as a weighting factor in a searches like text mining and user modeling. So like what Google does in a very fundamental way is kind of using the TF-IDF to get the part. And you see right, one of the simplest ranking functions is computer using TF-IDF for each query, and more complicated ranking are a variant of the simple model. So you understand right what is happening now. Can you see the word called relevance here? The variation
Yes.
of TF is often used in search engine as a central tool in scoring. The word scoring is being used, and ranking is also used for a given user query. The user query what we gave earlier is the term called Henry, right? That's a query what we are searching in a system. And it says that a given query and its various subject field including the classification. It decides, okay, based on the number it gives you some score. From that score, your document is being ranked order. If this higher rank, then you are returned back to the user with the result. That's the key idea here. Hope you are clear to this point, right?
Yes.
Great. That's the match query now. Now you understood what is a match query would look like. And there is something called match all. Without any filter condition, you are trying to search for the all the document. Again, if you notice here, all the document would be given an equal weightage here in the match all clause. Query match all. On doing this, you see here, right, all the document will be given an equal score equal to 1111. All the document would be given an equal score. It's something like regular to underscore search, nothing fancy here. The next query what we'll be doing is on the match phrase. Let me just pull up the match phrase here. Get slash mapping.elk underscore search query. You see something called match phrase, right? Now I'm gonna search with the phrase word. Now I'm using the same word called name. Now I'm just searching for the document which matches this phrase, the two words altogether. Still I'm not giving the complete one, but I'm giving a phrase altogether. Match phrase, is the field name correct? Okay. The name should be a caps here. Do you see here, right? Now it is returns a rank by giving the maximum score is level 11.5.93 and returns a document which matches the condition. So it has like 4 different matches for the given query like Aldi Acalum. So it returns me the result saying that it all matches the thing. So now we are giving like two words which combines to form the phrase over here. That's the match phrase. Now the third part is get mapping ELK underscore search query match paste prefix. Now the match paste prefix will try to emphasize that if you give some prefix to your search, like you should have the content in before. That's the key idea here. Basically, if you just give the hint saying that let's search with the word called Azir. Now the document consists of the word called Nazir is being displayed back to the user. Can you see here, right? If let's search for the Misters. Now it matches like 387 document which has the word called Misters and returns you the result back. Like what are the document it matches with the word called Misters here. And if you let's say if you want to search with the word called maybe let's pick it up with the dot or a Carolyn or let's use the word called base from. So now I'm just giving the prefix part. So whatever you should have the prefix content than the suffix part. Like what I'm mentioning here is now if you just say based from Mr. it should be in the prefix part. Only if the prefix matches, the second part would be retrieved back. Even if the order is different, if I just interchange this order, now this doesn't work because you have mentioned that the prefix this works by the prefix part. You understand, right, how the match base prefix works. Now the prefix will try to emphasize saying that ordering is very important. Hope you're clear to this point, right? Early in this case, if you interchange and run, it will work. If I go and change on the match phrase, now it returns me the 3 result. Even if I rerun and run it, let's see what happens now. Now the match phrase doesn't match a given condition, but again, if I just give the word called asim or adial, it is able to still return the result. The prefix will try to emphasize a condition, or you can use some partial word. Let's say the base from. See, I'm able to give a partial word here. I'm not even giving a complete word. I'm just giving partial word. I'm just keep on reducing. I'm just getting byst. Now you see here, right? I'm able to get a smaller subset. I can give like hen. Now what are the name it match with the hen just matched here. Can you see here, right? Henry, Henwick. Can you understand, right? How is that? How it understand how it relates? Hope you're clear to this point, right?
Yes.
Great. So this is with the scoring part. So that's the first level. That's the part like the algorithm they are saying here, how the algorithm works. I'll just explain the algorithm in a simpler fashion. Maybe I'll just like pull out. Yeah. Here when they mentioned, right, the full text search query, match query, multi-match, common query, simple query. The thing what we have to look here is on this part, the different term level queries. Terms, range, match, prefix, these are the different variants what you see in the system. Can you see the term query here, right? If you want to search in a specific field or only a single field, you can use something called term. If you want to search a given query in a multiple field, then you can provide the terms, which is the plural part of the term here. Just add the S here. If you, let's say, if you want to search for a product which contains a black shirt, now it should search on the product name as well as in the product description. So that during that time you will use something called term query on that. And what about the range query? If you are searching for the ages like age greater than 10 and less than 40, you are doing a range comparison, right? So for that range comparison, you will use the range query here. The second part, the exist part, it whether checks whether the document is exist in the system or not. The prefix part, like what is the like we are saw the prefix query, right? How the document should be prefixed in the wildcard. Even if you just go and give the star, it should work out of the box. If I just say Henry star, let's see how it works. See, now it can start to understand the star pattern. Look, while now it can able to see the Henry and followed by star. It starts to does the regular expression scan for you. Hope you're clear to this point, right?
So if you use star, that is acting like the wildcard search. It will bring up every word that
Yes.
starts with HEN, right?
Yes, you're right. That's a wildcard search. You're right. Clear till this point, Victoria, here, right?
Yes.
There is also a regex query. Wildcard will support like one or two normal operator. But if you go for regex query, now you can define like complex use case on the regex part. Still, you can go as complex as possible. That's on the regex part. Have you worked with regex question before, Victoria?
No.
Okay. This is like a glorified or the more detailed way of the wildcard search. It's also wildcard search, but you can do much more than in the regex query. That's the part I'm coming to emphasize here. Clear, right?
He said it will do much more than wildcard.
Yes, you are true. Yes. I'll just show you some example how the regular expression query really works in. You will be surprised to see that how complex or how simple you can make your life much more simpler way. If I have a name, Hari Ganesh, so can you see here, right? In this document, I have a two email IDs here. One is my email ID and one is something like very similar to yours. And I have free flow text and I have a number, okay? If I want to match all the digits over here, can you guess what could be the way to extract all the numbers from the given text? Can you think what can be done?
You call for like integers or something.
You see what I'm trying to do? It might sound like Greek and Latin, but it's way simpler. I'm using something called \d and using a plus. So can you see here, right? Now my numbers are matched over here.
Okay.
Only my numbers are matched. If I want to match only the email ID, I don't want to match these two content. I'm using /w, which is the word, and using the operator /w /dot. Can you see what is happening now here, right?
Yes.
So I'm able to, from a given corpus, I'm still effectively able to retrieve only the email ID from the document. I'm not searching the other space. My email ID is exactly pulled out from the document. Can you see the beauty here, right? I didn't write any complex code to write the extract the email. I wrote simple code, simple regular expression pattern, which can extract the content from the system. You're able to appreciate the power of the regular expression, right? That's what I said. It is much more powerful. If you go and type /star, now all the that's what you do it in the regular expression, right? If I just say Victoria star, if I use Victoria star or dot star, can you see here, right? With this entity, I'm able to search the entire email ID from your corpus. Can you see here, right? How it's done?
Yes.
Hope you can understand how it, why I said it's much more powerful, right?
Yes, because it's easier to search.
Exactly. You just give a try on learning regex regular expression, Victoria. It will be much powerful for your day-to-day activity. You will be surprised to see that how automatically or how effectively you can do your job if you know the regular expression. It's more powerful than what we think. Okay.
Okay.
So we are class we are left with the relevance part in the Elasticsearch. So you have any questions or doubt till the points, the contents what we have covered till now? You have any doubts or you have any clarifications?
No, I'm okay.
Okay, fine. Maybe this would be a last kind of more theoretical class we'll be having, kind of theoretical. From next class onwards, what we'll be having is like more of configuration the Elasticsearch and deploying the using the Logstash and FileBeat. So we'll be dealing with a lot of FileBeat and Logstash. So to try out in your maybe in your laptop, I don't think you can run your Logstash seamlessly. The reason is that Logstash requires like 3 to 4 GB of RAM to start even to do a small experiment. Maybe you can try Logstash in a computer. I will the once you download the exact package like if you are working with Elasticsearch, then you can start working with Logstash. Okay.
Okay, so you send me the link to download the Logstash.
Yes, right. So you can do it the after the class we can do it. Once we'll keep it ready, the Logstash. The only one requirement is you have to download the Logstash, which is matching your Elasticsearch version. make sure that you operate on the same version level. Don't try to take another version or a lower version. Try to see that or go to the old download if the recent download has been upgraded. So try to take the recent download from the what is it called, the Elasticsearch website. If you are facing some difficulty in that, let me know. I can help you with downloading the Logstash part. Okay.
Okay.
So let's understand the relevance part here. Once we are done with the relevance part, then we can proceed further. Let me just pulling out the information for the relevance part. I'm just sending this document to you, or this blog link to you in the chat. I'll just get you the holistic part. Can you see the mapping here, Victoria?
Yes.
So do you understand? Like, let me do one thing. Let me just copy and paste the mapping in the what is it called? The Kibana part. CD slash data ELK software Elasticsearch slash Elasticsearch. Okay, it's loaded, I guess. Mm, yep, got it. Okay, so I'm just pasting the content whatever I obtained from the website. Let's go out here. Let's do the same way what they're trying to do.
Just give me like 3 minutes.
Yeah, sure.
Hello?
Yes, Victoria, can you hear me? Hello.
Yeah, I can hear you now.
Okay, great. Shall we continue?
Hello, I can hear you now.
Okay, shall we continue?
Yes, let's continue.
Yeah. Can you understand what is being written over here, Victoria? Can you understand what is happening here?
We are trying to create an index.
Then?
And the keyword is going to be tokenizer.
So you have something called analyze here, right? You have something called analysis, and you have something called analyzer. So in that you see something called tokenizer equal to keyword. You remember the last class we are discussing about the algorithm, right? Term frequency and inverse document frequency, where we discuss about three important steps. One is the lower casing, the tokenization of words. Then we understood about the stemming. You remember, can you recollect what we did in the last class?
Yes.
So if you remember back on the key, tokenizer part, what I said on the tokenizer is dividing the whole paragraph into small pieces. That is what we understood something about the tokenization. Here the tokenizer, what we are looking here is something called keyword tokenizer. So it actually tries to divide the documents in the like words in document based on the white space, okay? And the filter is lowercase. On applying that unknown key index.
Jesus Christ, our Lord. Jesus, the Lord. But we also say our Lord God.
Then let's do this part.
Lord. Lord God.
Yes.
So you look at them.
So indent.
Everything is upside down, no?
Okay. I think it says that I don't have enough space in my disk, I guess. Let me see what is the free space. Hello?
I can hear you.
Okay. 1.3 GB speed. Just give me a second. Let me delete the content. The error, what do you see in my screen? Can you see the error here, Victoria? Can you see this error?
Yes.
Hello. So if you see some error, something called as a cluster block exception, and it says that something called index read only. So this indicates that your hard disk space is actually filling it up. So what happens when you reach like 90%, 95% of your hard disk space, what will happen is Elasticsearch will stop accepting new data. That's the first job. And the second job, all the data goes to something called read only mode. You can't delete something out of it so easily. So if you notice this kind of error, so it's highly indicating that you are running out of space. That's what it tries to indicate you whenever it goes to the overhead part. Still let's delete the
Everything is upside down.
mapper exception. Okay, let's skip this part. Maybe let's work this directly. I'm just indexing some sample documents here, Victoria. Nothing much here. I'm just indexing here.
Where's that? Mommy.
So I have indexed like 4 documents here. So let's query and verify the documents type here. Like what it comes.
Daddy.
Can you see the document being retrieved here? So it has something called libs as your index name and type as the book. And you have the author name, title, language, and year, and so on. So it gives you the thing. So like now the second part, what we have to understand here is, now we just want to understand how the relevance part makes a big impact over here. So to do that, can you see the formula over here? Hello.
Yes, I can see the formula.
Yeah, it says that score equal to Q into D, which is your query and the document. So this function accepts the query and document here, and you have something called query normalizer and the coordinate part. Can you see these 4 things here, right? The relevance score of the document for the query and the query normalizer, and the coordinate is the coordinating factor. Sum of the weight for each term in the query of document. So yeah, like can you see here? The TF-IDF algorithm comes over here. The term frequency for the term in the document D, and the IDF is the inverse document frequency. So it gives you for this. From this point, they do a computation part. So from this point, they start to do the computation. To understand here, now let's do the simple query here. So to do that, get /lib/search. Again, we just have to use something called query bool, and you have something called must and query string. The default field is they're asking the default field where you need to query it. I'm just giving the title dot
Got the last one.
I'm just saying some word called circle. Maybe let's search it again. Final years of I will take off boldly. Yeah, let's give the word called for. Can you see here, Victoria, what is coming on the right hand side now?
I'm trying to, what are you trying to do? You're trying to query, as in what's, this is supposed to search for what?
So if you observe here, can you see the score over here?
Yes, the score.
This score
1.31.
actually indicates that how much document is very relevant for your query. So we did some query here, right? So you say the query here is like a for statement, or let's say something called a bell. On performing the bell, it says that it is having the maximum score of 1.31.
Okay.
So like coming back to understand like the scoring part, if you remember back on the what is it called, the Titanic website, the mapping.elk. You remember the mapping.elk example, right?
Yes.
So like if you look on the mapping.elk, so we have a lot of different names over here. In the same query, I'm just replacing with the thing called Mr. over here. Yeah, give the content call instead of the name. I just type name and type Mr. Can you see here?
Okay, so you're praying for Mr.
Yeah. Now I'm doing for Henry now. The first I gave for Mr. Now I'm choosing for what called Henry now. Because Henry has like a lot of different combinations here. You see the word first call here, right? I'll just copy and paste it in a different editor for a maximized view. This is one type of Henry here. And the second type of Henry, what we have is here, hat Mr. Henry. Second type of Henry here, Mr. Blank, Mr. Henry. Blank, Mr. Henry, Henry, Mr. So now you see 4 different examples for the Henry, right?
Yes.
So if you see like 4 different entry for the name called Henry, so if someone, the user starts to query the document, I just want a document containing the term called Henry, or think of the other way around. You are going to some e-commerce site and you are searching for some books. Okay, you want to search some book which has the word called computer, or you want to search something called maybe a networking. If you want to search something in our e-commerce portal, what happens behind the scene is whenever you query something like that, now your search response, you should get some relevant books, right? If you have a book, something on network programming, and there is a book containing only one time the word called network, do you think what book should retain on the top, Victoria? Hello?
Hello.
Do you understand what I said?
So this is used for text search.
Exactly, yes.
Okay.
So
So
whatever
this
you're
is
getting
probably
out,
what Netflix uses. So this is the type of search or query that goes on Netflix.
exactly, yes. If you are searching from genre or some movie name, so you might have like 2 or 3 movie names on the same thing, right? Like if you go and search for Terminator, like Terminator has 3 to 4 parts. Again, for Jurassic Park also, again you have like 3 to 4 movies, right? If you type only
Yeah.
the word called park in your Netflix search engine, now now your Netflix should return you the movies which are more relevant for you, right?
Yes.
So that retrieval is done using the algorithm what we discussed in the last class, something called term frequency and inverse document frequency. You see the score over here. Can you see the score here, right? 3.7 is the first score. And if you see here, now it comes like 3.6. If you go down, the score starts to decrease as it goes on. Can you see there, right? Now it goes like 3.286. It keep on starts to reduce your score. And that's where it says that your document should be relevant on this scenario here. Hope you understood, right? How the relevance actually works
Okay.
here.
Yeah, now I get it.
Okay, great. So that's what I was trying to convey you. Whenever you're doing like something here, whenever you see the order of the document is in a different format than you expect, then it's the right time that you have to focus on your relevance part. Okay, that is the fundamental entry here. You're clear till this point, right?
Yeah.
So now this topic will require like a 1 hour of solid part. Now let's continue this topic tomorrow. I'll bring another laptop of mine. Let's configure the Elasticsearch with the cluster one. So now today to begin with, to like have like I'll just give a like overview of what is Logstash and what is the specialty here. So do you understand what is a Logstash and a file beat, Victoria? You understand the difference here before we start?
No,
No, I don't know anything about Logstash or 5-bits.
Sorry, come again.
I don't know anything about Logstash or 5-bit, but I know like it's like the pipeline for getting data into Elasticsearch and Kibana.
Perfect. So Logstash is a complete system which can collect the data from different source. It can collect, it can parse, it can filter, it can send to a different system. Okay. So you would see like 4 different operations over here, right? It can collect the data, it can parse, it can filter, it can send to a different system. So this is actually called as ETA tool. Okay. You have heard about the ETA to extraction, transformation, ETL. Sorry, it's not ETA, it's ETL. Have you heard about this part before, Victoria? Extraction, transformation, loading.
No.
So to begin with the if you just go and type on ETL in internet, ETL. I'll just get you the picture here. Can you see the picture on this side, Victoria, here?
Yes.
Can you understand can you explain what is happening here?
Yeah. It's extracting different sources. It stores them or transform them and put them all together and send them to another device.
Okay, I'll just get you the different part now here. Can you see the same picture here? What is happening for the ETL? I'll just pull it for a better picture. Maybe just give me a second. I'm just pulling out the other picture. Can you see the picture over here? This is like a more easy one. Can you understand the picture here?
No, this one is smaller. Okay.
Okay, let me make it easy.
Transform.
So if you think of Logstash, I'm just pulling out the thing for Logstash also. I just search for the same thing for Logstash. You understand this? Understand the picture here. If you click on the Logstash here, can you see the Logstash picture here? It also collects data from different source and stores in some kind of engine over here. And let me take a different picture. Can you see this picture here? It says that popular data source are the IoT device, web app, database, message queue. From all of these different sources, it collects the data and it sends to the Elasticsearch. It not only sends to Elasticsearch, it has like other features also here. Can you see here, right? The input comes from a different source and the filter and transformation happens in the Logstash. Once it's done, it goes to the Elasticsearch. Once the data actually goes to Elasticsearch, we can start collecting the data from the Kibana part. Then we can start visualizing data here, right? You understand what happens in different ETL tool and the Logstash part? You understood this here, right?
Yes, so the ETL collects, so the Logstash collects and transform data for use in Elasticsearch.
Yes, but if you think of the file beat, it can only collect and send data to Logstash or Elasticsearch. So it can't do any parsing, or it cannot do parsing, filter, or any other transformation. That is not possible with the file beat. Okay, so you understand, right? Logstash can take the data from different source, then aggregate all the data, then it can filter, it can do like a lot of simple operations. It can truncate transformation and it can load into Elasticsearch or some other system. In case of FileBeat, it can only collect the data. It can't do much more than that. It can't do the parsing. Like if you think of a Logstash is a complete system, whereas the FileBeat is like a small subunit in that. You understood what is the difference between the Logstash and a FileBeat, right?
Yes. So Logstash can collect, parse, filter, transform data, while Firebase only collects and sends to the Elasticsearch. So no transformation takes place in Firebase.
Yes, right. So that's the fundamental difference between the Logstash and the FileBeat. You understood the gist here, right?
When you put your finger in your mouth, have you finished the popcorn?
Yes.
You are clear the difference, right? Because this is like a kind of very important thing you have to
Can you see
understand.
properly?
Yes,
Because
I
the
do.
people, the main reason why they have developed something here, because the initially in the before release of Elasticsearch, you had only Logstash. There was no FileBeat. FileBeat actually released like a couple of years only back. So the reason why they introduced a FileBeat is like Logstash is kind of a heavy system. You have all the functionality. Eventually, it will be like a heavyweight, right? So that's the reason like it is FileBeat has been developed here.
Okay. So you use Firebase if you don't need any form of transformation for your data. You just need like a pipeline to get it from one place to another.
Yes,
So
right.
that's when you go for Firebase.
Yes, right. If you just see FileBeat and Logstash architecture, you will get the big picture here. I'll just take for a good picture over here. Maybe just give me I'm just searching for a good picture here. Yeah, I think I got it. Can you see this picture here?
Yes.
It takes the data from a different log file and FileBeat sends to the Logstash. Now the Logstash only does the parsing, filtering, and transformation. Then it sends to Elasticsearch. You are understanding the flow here, right? What happens now?
Okay.
So let me just give you the another picture, maybe to explain in a better sense. FileBeat. Can you see here what happens now? So FileBeat collects the data from different source and then it sends for the Logstash. Now Logstash will directly work with the Elasticsearch in the backend. Now it interfaces with the system in the backend. So basically what it does is your Logstash is a kind of heavyweight system. It kept in a one single machine. So all the FileBeat small modules will send the data to Logstash. From Logstash will go to the Elasticsearch. Okay. Hello. Hello.
I can hear you.
Yeah. So the file beats like the small units. For all these small units, it sends to the Logstash. From Logstash, the operation actually happens over here. That is a gist over here. You got it. That's the reason, full fundamental reason. Anyways, we will understand from tomorrow's class in detail about it, Victoria. Please download and keep your Logstash up and your Logstash version in your machine ready. So tomorrow we will configure Logstash and start pulling the data from several different sources. Okay. Great. So can you see the Kibana console here, right? Till this point, like whatever we discussed in our past class, we just use the dev tools in Kibana, right? We have never explored the other tabs in Kibana. We started the Kibana here, and we directly came over the dev tools. And dev tools, we used to try out the different queries, and we come back to the Python console, right? We did nothing fancy in the Kibana, but to start with the Kibana part, Kibana consists if you just want to ask me what is the language has been designed is the backend is completely written in Node.js, Vinod, and the front end has been written in the AngularJS. The first AngularJS one, it's what the framework has been written on. So the Kibana, if you ask me, like Kibana, can it work without the Elasticsearch? It can't work without Elasticsearch for sure. Only if your Elasticsearch is up and running, you can really work with Kibana. If you are trying to start Kibana without the Elasticsearch being running in a machine or it's not pointing to the right IP, then Kibana itself doesn't start for you. So Kibana is slightly coupled, but it's not the other way around. If you want to work with Elasticsearch seamlessly, then Kibana is not required as a tightly coupled application. You can use some other UI application which might be designed by your organization on your own, or else you can use it a different kind of application too. There's a tool something called as a Grafana. Have you heard about the tool Grafana before?
No.
There's a tool something very similar to the what is it called, the Kibana, which also does the same kind of visualization for you. So it also helps you to create the chart and have the same look and feel. I'm just opening it for some live demo for you so that you understand how it looks. Can you see the items over here, right?
Yes.
So this is another alternative for Kibana in the market, which is something called Grafana. Few things are available in Grafana, few things are available in Kibana. But generally, if there is a big company or MNC, they try to capitalize the both. They use both Grafana as well as Kibana in their production machine. If they are monitoring some instance, that's only for the monitoring. For the searching purpose, Kibana itself is more than sufficient. Just for monitoring purpose, if you just want to monitor something, they try to use the Grafana. Clear, right?
Yes.
Okay. Now your Kibana consists of a different tabs. Let me explain you one by one. The first tab is something called Discover, Visualize, Dashboard, Canvas, and you have like a lot of things. In the out of these tabs or these option, there are like five critical elements or five critical tabs which you have to master. One is the Discover dashboard, and next is the Visualize and the dashboard, and you have to also master the dev tools which we already discussed, and next is the management one. Why I'm just saying all these five tabs are very important, right? The only these are comes under the free version or comes under the non-paid version. If you want to start using other tabs, you have to pay for Elasticsearch for sure. You have to buy the license from them, then only can start using those instances. Clear, right?
Yeah, it's clear.
And regarding the logs and logs part, it's something, it's more like a wiki page. If you just open the logs here, they would have given how to collect the logs from a different kind of infrastructure machine. Let's say if you want to collect any log from, let's say Apache Tomcat, or if you want to collect data from your MySQL, this will give you the instruction. Do you see the information over here, right?
Yeah.
So they have something on RS Spike, Apache log, Apache metrics, Cisco log, Couchbase, and you get to see like lot of things over here. Logstash, MongoDB, and you get to see the Nginx, Postgres, everything over here. The Windows Server log, Zookeeper, and everything. If you want, let's say this is a wiki page. You might be surprised to see that, but if you just go and click on the MySQL log, they will say like how to enable this module in a particular your machine and get the job done. It's kind of more like a wiki page. So the logs is not completely a particular feature or a tab. It's kind of like a wiki page. Clear?
Yeah, it's clear. So I have a question here. So what if I want to learn everything, whatever we are displaying on the UI? I mean, on the left hand side, there are many. So you said like some of them are need subscription, right? I
Yeah,
mean, license.
yeah, right. So in order, if you want to learn such all the tabs over here, there's an easy option for you, which is you can activate the trial license from Kibana, from Elasticsearch. They give you like 30 days of free license for you. You can try out all the feature. You can play around that. Then we can make your hands dirty with it. Clear?
Yeah, clear.
Maybe for you, if you are really curious to learn all the different tracks, I can help you with setting the what is it called, license in your machine. I can, but make sure that if you set up a license in your machine once, you can't set up the license in the near future. They'll have something like antivirus check. They have a proper mandatory check. You can't have the license in the near future. Clear, right?
Yeah, clear. But I can use if I want, I can use it other mission, right?
Yeah, that is you can do it. If you have if you can keep on activating a different mission for sure. That won't be creating any problem because license cost of XPack is some crazy value because it depends on number of nodes you work on. You just have to pay like 4,000 euros to get a license for a given node. It's not 1 rupee or 2 rupees, 4,000 euros. It's damn expensive. Then I just inquired some time back. It was super expensive to get the license. Clear, right?
Yeah, clear, Hari.
Okay. Maybe let's start from the dev tools once again. And dev tool, let me just list the list of indices available in the instance. Do you see these are the indices available in the instance? You see, right? Session 03, you get to see something called mapping or ELK. You get to see a different what is it called index name over here. Now I'm just going into the discover tab. So discover tab will help you to search a content. Now do you see here, right? In order to visualize and export data in Kibana, first you need to create a pattern from Elasticsearch. I'm just clicking the discover tab. It is obviously taking me to the management console. Do you see the top here, right?
Yeah.
Why? Because sometime back I have destroyed all my data in Kibana, so it doesn't have any data point. So the first important step you need to configure for a given index is the index pattern. So I'm just configuring the mapping or ELK. I'm just clicking the next step over here. I'm creating the index pattern. After creating index pattern, now you remember the Titan data set, right? Yesterday we did using bulk indexing. You saw data set, right? Regarding the person who have survived the accident or did not survive the accident. You saw the data set, right?
Yes.
The same data set we actually I'm also displaying here. In this, if you see that age, embark, and all the details comes over here. And now I'm going back to the Discover tab. Now it will go without any problem. On your left, you see the mapping.elk, right? This is the index name currently being configured for the Discord dashboard. If you have the multiple index being configured, you have a drop-down menu where you can pick the what is the index name you're looking for. Clear?
Okay. So our index name is mapping ELK. Is it correct?
Yes, right.
So how are we displaying it here? That indices.
Sorry, come again. I didn't get the what you're trying to ask you, Prit. Can you come again? What is it you're trying to ask me?
Yeah, this indices, this index, this mapping, this data, this information we are displaying here, right? So how did you come to here? I mean, what is the starting process? First step.
The first step is to discover here.
Okay.
Click on discover. If you are not able to see any data, you just have to configure the management API first. You just have to go to the Kibana index pattern. That's the first point. First, after you create an index in Elasticsearch, if you want a result to be displayed, let's start the meeting. Yeah, fine. Yeah. If you want your data to be displayed in Kibana, the first step you have to do is you have to come and click on the management icon on the left hand side. Clear? After clicking the management icon, you have to click on the index pattern. Clear? After clicking the index pattern, you just have to click this option called create index pattern. After clicking on the create index pattern, now what are the different indices present in the system is being displayed. Now if I want to add the session 03, I'm just adding it over here. Clicking on the next step and create index pattern. I did my job. Now if I'm going back to my Discover tab, now do you see the drop down menu is being displayed over here on the top left?
Yeah, because you have added two, right? This mapping on session 3.
Only if you add the index name in the management console, you will be able to visualize or search or do any sort of operation in Kibana in these 4 tabs. Clear?
Yeah, clear. So let's say if you don't have any indexes, we can create it from there, right? There is option.
You can't create it from any indexes here means I didn't get it precisely. Come again.
So when you click on that index pattern on the right hand side, there was option like create something. There was option, right, with plus symbol.
Let me just get you index pattern. What is it you said?
Oh yeah, okay. Sorry, that is create index pattern. Okay, on the left right hand side with
Yeah.
plus symbol and blue color.
It's an index pattern alone. It's not the index itself. It's an index pattern alone. Only if you have data with the index being done, you can do such thing. If there is no data here, if you want to create any new index, like if you want to create something called session 04, that is not possible. If there's already data existing in Elasticsearch, if you want to add some pattern to it, you can do it over here. But you can't have it on your own. If you like creating one index, that is not possible.
Got it.
Great. Going back to the Discord dashboard again. Now let me select the session 03 because that is a very small amount of data. Do you see the items over here, right?
Yes.
So on this part, you have something on. I'm just having only one document on my session 03. So you have the following entries, which is the ID, underscore index, score, type, name, and version. You get to see all these informations on your right hand side along with the JSON field, right? If you want to display something, what you get on DevTools, you can use this option, or you can use the table view to get the job done. Clear?
Yeah, clear.
I'm just switching you to the mapping ELK because that gives you like a better control of the system. So now you have like lot of fields in the what is it called, the given file. You have the age, fare, and everything. Like in select start statement, if you want to specify the column name, likewise you can also select the column name which you like to display on the right hand side. If I want to display the age, and I have to display the gender, and I have to display what is the they have survived the accident or not. If I'm clicking this three option, can you see the result on the right hand side, right? Only the selected column is being displayed on my to my right.
Yes.
So you get to see the age, gender, and survived or not. You get only these three options, and it's being displayed to you. That's what is happening over here. Likewise, if you just want to expand a given field, like if you want to expand this particular column here, you will see a small top right side arrow, right? On clicking this option, you get to see the expanded option. You see here, right? Age, embark, fare, and all the details comes over here. Clear till this point?
Yeah, it's clear.
If you want to revert back to saying if I want to display all the fields in Kibana, you just have to click on the remove button over here. After clicking the remove button, all the result would be displayed to you. So just refreshing it once. Do you see the items over here, right?
Yeah.
So now it displays all the content for you, the fare and everything. That's what on the left hand side, and you understand what is there. For example, if you want to do any free text search, like we used to do in Google search, right? Something like that sort. If you want to do it, I'm just selecting the word called O1 and just directly pasting it over on the search console. After entering that, do you see, right? It displays a document where I'm able to see the word called O1. You can see here.
Yes.
Is something very similar to the what is it called, the in Google search. In Google search also we try to specify the keyword, right? Here also you can try to search with the keyword. If you want to search for any particular value, something called 21171. If I just want to give some random one called 21171, can you see the difference here, right? So document which has the word called 21171 was only displayed to the Kibana console. Hope you are clear right till this point.
Yeah, it's clear.
Okay, now let's try to go much a little deeper into the Kibana Discord dashboard. Here, if you want to, you can also search by the column name. Till this point, the type of search what we did Kibana is we are searching across all the document or across all the field in a given index. Let's say there is a use case where I have to search only for the particular column. Then the option you need to choose it. You just have to say the ticket. You see here, right?
Yeah.
If you start typing the ticket here, and then you'll be prompted with something called colon and not equal to or exist or and operator. Now I just want to give the colon. I just have to say 21171. On typing entering it, I'm getting the same result. If I just want to make the or condition here, see it's being displayed to you or, and if I just want to say the age equal to 27. Now do you see, right? Now both the result which is matching the condition for the given ticket and matching the or clause which also and this and is being displayed to you. So the condition which is either matching the 27 or either 21171. So the displays both the document. So you can see the number of document is being written. Do you see the number of hits here, right? Totally it matches you like 57 documents altogether. Clear?
Yeah, clear. But what is the ticket? Is that a method or command? What is that?
Ticket is a column name here. Do you see? Do you open the file I shared with you yesterday, right? Ticket is a column name. What I had on your left. You see the ticket name on here.
Okay.
These are your column names from your column names or the field names in the JSON document. Maybe I'll just
Okay.
show you that.
Yeah, I got it. So before that, so we tried searching it. I mean, like enter the document. Now we are searching it based on the columns.
Exactly. So
Yeah,
also
got it.
you need to understand that we are able to give the conditions over here or are not condition. You are able to specify the conditions here. Can you see this or condition over here, Vinod?
Yes.
So like in Google search, I'll just do a Google search for you to understand this part. If I search for your college,
KUPPAM. Kupam, and the place is also Kupam.
this is the college, all right,
Yes, that is the one.
but this in Andhra Pradesh.
Yeah, that is Andhra Pradesh. I mean, that is close to Tamil Nadu.
Okay, understood. Yeah, fine. So if I just want to add one more condition saying that and maybe well, let me give a word called what else I can just say here. Okay, just want to say and fees over here. See, it displays only the document which is matching the condition, both fees and the college name. Do you see here, right? Earlier it was displaying all the details over here. Now it's displaying only these two information. Or we can have a much simpler thing, India and France. If I just using this word, see France in India, the document which is matching the condition is only being displayed over here. Do you understand the difference here, right? If you see on the top left, what I'm just hovering, can you see this part?
Yeah.
So only the document which is matching my condition is only being displayed to you. Hope you're clear, right? This is what
Yeah.
happens when you start working with these kind of enterprise systems, where in which you get to see you can provide the and or clause to that, like and condition or condition. From that point, you will be able to access the data point. Clear, right?
Yes. So is it like, I mean, like minimal search? I mean, we are applying like filter kind of thing. I mean,
Yes, Vinod. So you can try to specify the option. You can start to write the complex query by building as you go on. So right now we just saw the CRUD operation, right? We never saw any advanced CRUD search operation in Elasticsearch. This is to begin with. You can start giving your advanced queries over here. This is the first level. So where with the help of UI itself, you can frame your search request. The search request will try to get the document for you.
yeah.
Any questions?
No. Yeah, it's clear now.
The beautiful part over the Kibana dashboard is you can save your queries like a stored procedures. You can go and click on the, you see the three options here, right? New, save, open, share, and inspect. I'm trying to do something called save over here. Now I can just say this something called save query 1. If I'm doing such a entry, so save query 1. Now next time if I just refreshing it to the Discord dashboard for new time, so now you see right 2673 document is being displayed. If I just want to open my old queries, I click the option called open over here and select the save query here. After doing that, see automatically my search result is being modified over here. Do you see the difference here, right?
Yeah.
So that's what is happening here. Next, we will see on the sharing part. You can share this as a CSV report with other people. That is also possible, or you can serve as a permanent link. You can share it as short URL. So let's say if you want to open to some other team, I'm just creating a copy link. I'm opening a new tab and pasting the short link. After pasting the short link, again my search result would be always will be copied from the other tab to this tab or anyone in the organization. You see here, right? I never had this many information. I just had this small copy URL. Copy URL just had the same information or the same search request.
Yes, got it. Yeah.
And this important thing what you can do is on the inspect part, like kind of like a profiling entry here. What are this for a given search result? How many documents been hitted in the system? You get to see all the meta information, the statistics part, the index name, the index pattern ID. You get to see the request. What is the request being fired from the system? You get to see the request name here, right? So this is the queries being fired internally by Kibana to get the result what you're looking in the screen. Clear?
Yeah.
And you can also see look on the response part. On the response part, you see on the top bottom right total time the request took, and you get to see the complete data from the instance. Like you get to see in the dev tools, right? The dev tool result has been properly modified and formatted and displayed on your Discord dashboard. Hope it's clear, right?
Yeah. So this JSON this request and response. So this is to generate this query, correct?
Yes.
I mean that data.
For that, you let me just take you here. This is the request and this is the query. For this query, this is the response over here. Clear?
Yeah, right. So that request, I mean that request we are sending in JSON format when we hit that ticket 21171 or age 27. Is it correct?
Sorry, come again. It
So now,
query or JSON what we are firing it from Kibana. After that,
so my question is, so we are sending the request. So this request is to, I mean, to find out what are the matching values, like age is 27 and
exactly yes. If you see here, you see the entries over here, right? Age is equal to 27 and ticket number is 21171. Do you see here?
yes.
Exactly. Whatever you said is correct.
Yeah. So, and one more thing is like here on the right hand side, we are displaying it in a JSON format. If that is source is like in like a database format, I mean like table format. Is it correct?
That is being formatted properly because everyone can't read JSON format, right? It's not user friendly, right? Sometimes it becomes a very cluttered part. Like if you take any end user, it becomes very troublesome to look on the JSON part, and again, it's like consumes my lot of space. But if you see here, now it's beautifully formatted and it's only displayed with the respective column. Now you understand, right?
Yeah.
Yeah. Any questions till this point?
This is understood. So in this Kibana, so what are all the things we are going to use it in real time?
Okay, we'll see that. That's the point we're gonna see. You're clear the Discord dashboard, right?
Yeah. Yes, sorry.
Yeah. And let's go to something called as next important tab, something called as a dashboard. Dashboard is a place where you can start creating your bar chart, pie chart, and all sort of, maybe you should go to visualize first. I'm wrong. Yeah. Create a new visualization here. You can create one based on a data. Do you see a different types of charts over here, right?
Yes.
Let's pick up the simple one, which is the pie chart for our case. We just click on the mapping.elk. Now, if I want to click on the aggregation, so aggregation, what I'm trying to do is the simple group by command. You understand the simple group by command on the gender, right? What if
Yeah.
I do a group by command on the gender? I'll get male as 25 and female as like 50, means that is the group by and the count, right?
Yeah.
The same thing, there's a different word they use, something called aggregation. Group by alternate term is aggregation, which we will see in later class, but just try to understand the bigger picture here. Now I'm just selecting the passenger class, P class, yeah. I'm using same count statement here. I'm just clicking on this point. Do you see the result on my right hand side? Now it says that with passenger class 3, this is the distribution, and this passenger class 1 and passenger class 2. Do you see the category, right? Like in the gender, we are able to have this information. Likewise, if you just want to click on something called gender, that also is the same result. Do you see the result here, right? Male is like 64% and the female is 35%. Do you see the comparison here, right?
Yeah.
That's what is happening. You can save this dashboard. If I just want to save this dashboard, I can click and just say my first buy. I can confirm it. Again, there are a lot of options involved over here. You can click on showing the legends here. You can click on the label and you apply here. This will be displaying like an Excel or spreadsheet. This displays the complete information over here. What is the label you are looking on to it? What is the male and female ratio? This gives you complete, instead of hovering this information, it displays a legend on your top right. Clear?
Yeah. Clear.
Again, if you want to have the traditional pie chart, if you remove the donut part and if you run it, you get the traditional pie chart. Pie chart and donut are the same. If you have the hole in the center, the pie chart becomes the donut. Clear?
Yeah. Clear.
Okay. Now let me show you a dashboard which would look like actual real time. I'm just searching for info here. I'm gonna set up the sample dashboard which comes with the Kibana itself. I'm just gonna do something over here, discover logs.
So I have one question, Hari.
Yes,
So if I want to see, I mean, like I could see in companies, so to maintain the, I mean, like services performance, we also display this dashboards, right?
yes, true.
Okay.
Like generally,
So
where people were, I'll just say different use cases where company would generally use. If they have the multiple clusters running in their office environment, it can be MySQL or Postgres or any different server. If they want continuously to monitor the system, then they are using Elasticsearch to continuously monitor the system and take the corrective action. That is one such use case. Or else people are using for some kind of searching operation, like if they want to search any specific data like Amazon or Flipkart, people use Elasticsearch. Or else people just want to do some kind of machine learning data analytics, they are using Elasticsearch. Clear, right?
yeah.
What are the different use cases? People are using the Kibana and Elasticsearch together as a coupled pair. You see the install some sample data, right? I'm just clicking the install sample data. I'm just want to get this two dashboards, as sample e-commerce one and sample flight data. I just want to get these two sample data, or maybe we can get the sample web server too. Let's see how the web server, the dashboard traditionally looks in Kibana, and also we will try to create our own dashboard so that we get comfortable with the with working with the instance. Okay, so we create the pie chart, right? Let's see how to add our own pie chart to the system and they get the job done, because we just use only one version of the visualization, which is the pie chart. If you see all the like lot of things are available, I'm just clicking on the e-commerce portal, I'm just clicking the dashboard here. It's getting loaded. Let's give some time, get it so I get it out. Can you see here?
Yes.
It's now displaying the complete information like sold products per day, sales by gender, average sales price. So again, for e-commerce website, not only for searching, if they periodically want to understand what is the sales report, they are using these kind of systems. Total revenue, sales by category, what is category they are having a better sales. See, men's category they are having a better sales over compared to other products over compared to men's shoes, and the revenue tracking and which region of the country around the globe there's a lot of sales, top selling products, and your categories over here, and you get to see complete information here, right? This sort of happens in a dashboard. Maybe let's pick out a different dashboard, maybe a web traffic, web server traffic. Do you see on the right hand side, right, the screen here, right? What are the things? See, if I just want to select the country name, if I just want to select the country name called IN, let's say that India's there are not. Yeah. See, it gives you the complete information. What is the request is being originating from a given country. See, can you see this option here, right? Now in the map, it is being completely displayed for the only the country name. Can you see the map here, right?
Yeah.
So these lot of informations can be done with the help of these kind of dashboard. If I just want to select one more country called JP is for Japan, I believe. Let's see whether the Japan is born displayed over here. Do you see the Japan has been displayed? Do you see here, right? Can you see that, Vinod? That's why the Japan is being highlighted here.
Yeah, Hari.
So this is where you see you can create a lot of charts are available in Kibana. You can do something called gauge chart. You get to see the normal pie chart. This is something called bubble chart with the vertical bar, and area chart. This is called something called area chart. You get to see the normal data tables, scatter plot. We have something called Shanky chart. This is like an advanced kind of visualization technique what you can get from this system. And this is the traditional maps. And this is something called heat map they call it. In which point of region there's like a lot of heat or there's too much of data inflows in the system. See the India point, there's a lot of requests comes here. Like in the indication of the numbers, they indicate the colors over here. That is what the heat map is trying to convey here. Clear?
Yeah, Hari.
Great. So now let's try to create our own dashboard. Now I'm just clicking new dashboard, and it says that add button. I'm just clicking the add button. And now it says that what is the chart you want to add. I'm just selecting my pie chart. See, if I'm adding my pie chart over here, I'm able to see the result. Can you see the result here, right?
Yes.
This is what happens when you start creating the visualization one by one. You will able to get the corresponding results on your dashboard. We can start adding it, and the beauty part is you can expand or shrink it based upon and depending on your need. You can shrink it of this size, or you can make it to this size also. It's all completely under your control.
Yeah.
Clear?
Yeah, clear. So
Perfect.
to build all these dashboards, these pie charts and other graphs, so we need to use that, mapping that commands, right?
You just have to come and click on the visualization part and select the visualization what you like to do. If you just want to use something called tag clouds. Tag clouds is for displaying the names over here. I'm just selecting mapping.elk, and now I want to select the tag name as something called the names in my document. If I'm selecting the names, I'm running it to it. Do you see here, right? My tag cloud is being displayed over here.
Got it.
Likewise, if you want to create some different thing called maybe a gauge, select the mapping ELK, and you see this is the total number of documents in the system. If I want to split the group based on the aggregation called term, and if I select the age over here, I run it on the this is filtered. If I select the median value, not the median, if I just want to come and click on the option called the split group, if I select the option called terms, and if I select the item called fare.keyword, you see here, right, different kind of fares available in the system. It just displays in a different chart for you. So what is the total number of document is matching the condition? 129 document is matching, and what is the fare? 805. So that is the base price that people have paid for taking the ship. You see the difference here, right? Likewise, we can start displaying the multiple charts from the visualization. You can also select something called the vertical bar chart, which we used to do it often with the spreadsheet. I just want to select the x-axis. My x-axis is now I just want to select the, I'll go with the same gender. Now it displays me the list of genders on my left, male and female. What is the document count? Do you understand, right, how it works?
Yes.
You are clear to this point. You just have to practice it here once more. You have to start practicing lot in Kibana. Vinod.
Yeah, sure, Hari. This looks interesting.
Yeah, because if you start, you try to frame an example. You try to today play around with this, okay? Once you are getting comfortable, I'll just give you some assignments to work on Kibana dashboard. I'll give you like what are the use cases you need to display and what are different types of charts you want to explore. I'll send you detailedly over the weekend. Tomorrow's Friday, right? If I'm not wrong.
Thursday.
For India, it's India is today is Thursday. I think yeah, it's fine. Yeah, maybe we will try to explore it. Once we explore it by today, try to practice it by today itself. Then only we feel comfortable with this part. Maybe from Friday on the over the weekend, I'll give you assignments on Kibana as well as on the Python. You try to solve it. Once you try to solve this part, you will really get comfortable with the system on the whole. Clear?
Yeah, sure. I'll do it. Yeah.